Okay, so prerequisites for today, it sounds like most of you fit the bill. You're either in DevOps, you're a system administrator, solution architect, etc. We hope that you have some at least prerequisite understanding of Nginx. So either you've taken some of our courses before or you've just been using it for a decent amount of time. We also hope that you have some familiarity with Linux and text editors, just because if you haven't touched it in a while, it'll be hard to get through the labs. Also, having some solid understanding of network topologies will help as well. Okay, so what's part of the training environment? Well, you have SSH access to an EC2 instance, and it's running Nginx R16, which is our latest release, as well as the dynamic module for mod security, which we call WAF. It also has what's called the damn vulnerable web application on it, and we don't use it that much, but it's just there for your personal testing. I'll leave the machines up for about a week if you want to go off book and off script with our course material, and if you want to do some sample SQL injection testing or cross-site scripting and testing on that application, we will set it up, and then you can basically go nuts. So that's there for your leisure. We only use it a little bit in this course because it's just kind of an 8-hour course spread over today and tomorrow. But if you have any questions about that, I can try to answer them. And if I can't, I'll point you to the documentation for how to get it to work. Okay, so I lied, William. Sorry, we're going to SSH into those machines now because I think we need to do some prerequisite lab steps. Did you get it working yet? Maybe audio connection?
Hey, Bill? Bill, you there?
Maybe he's AFK. That's fine. Okay, so why don't we SSH into each of our machines? And by the way, before we continue any further, in the materials section of GoToTraining, I have these slides in zip format. So if you download them, I don't know if you guys see them, but basically it says securing-applications.zip. And if you download the files and you extract them onto your local computer, you should have an HTML file. And that's pretty much what I'm looking at here. And the reason it's HTML is because it's easier to copy and paste certain informations, which will become pretty important when we get to something like JOT authentication, for example. No one wants to type in that base 64 encode stuff. So anyway, so why don't we SSH into our machines? And the next step, we're going to deploy the web application. So we're actually running Nginx Unit, which is another product we have. It's a lightweight application server. It kind of replaces things like PHP FPM or UZWig and things like that if it's Python. And these are the commands you're going to run when you first start. So you're going to run, by the way, we're using sudo for everything because unless you want to change to root, you can. So we're going to run sudo service unit restart and then sudo service PHP 7 FPM restart. And then once you've restarted those two programs, we're going to use the API command, the Nginx Unit API command, to ensure that our socket listener is up and running, and that we actually have the application objects and listener objects for Nginx Unit to display. So I'll go ahead and SSH into my machine. You guys can feel free to follow along. Okay, so I am student 1. And you can use either your EC2 host name or the DNS name that was given to you in the email, or at least I hope it was given to you in the email. If not, I have it for you. Okay. All right, so I'm in my machine. The next thing I need to do is restart those processes. So I do sudo service unit restart. And I do sudo service PHP 7 restart. And then finally, I'm going to do that API command. So I'm going to use curl. And we actually have to ping the Unix socket. It's running on var/run/control.unit.sock. And then I believe the name of the endpoint is config. Okay, so this is actually the port that the application is listening on. So it's 8090. And then this, of course, is the application object itself. So it's basically saying it's running on PHP. It's access to about 20 threads. This is the root index directory, and this is the index file. So if you're not familiar with unit, I feel free to Google it and look it up, the documentation. It's pretty cool, but I'm not here to sell you on unit. It's just what we're using.
Sorry, James. Are we supposed to be seeing your SSH terminal?
Yeah, we're not seeing your SSH console.
Oh, really? Okay,
Yeah.
let me reshare my screen. How about now?
And my curl command is.
We just see the lab.
I think we're seeing one screen, not the other. There we go.
Oh, almost just saw it. Now we see it.
Okay. When I switch back and forth, do you see the slides? So now do you see the slides?
Yes.
Okay, so there's something going on with GoTo training. Thanks for telling me. It would have been awkward if you thought I was not doing anything the whole time. Anyway, okay, so these are the commands I ran. I ran sudo service unit restart, sudo service php 7 restart, and this is the command that I ran after I restarted those processes. So I can actually copy and paste these for you, if that's easier too. At least the curl command. And this is what you should see. So again, applications running on 8090. It's listening on all IP addresses on this interface, port interface, and then this is the type of application. Okay, so let me know when you guys.
Chris, mine's failing. I'm not sure what's going on here.
Which step is failing?
The curl command just says can't connect to the server.
And you restarted unit and PHP 7?
Mm-hmm. Yeah. And I look at the config files seem to be correct. I see it listening on 8090.
Try doing this command here. Try doing sudo curl-x. I'll copy and paste this if it's too much, and then we'll do @var/www HTML. Basically, we're pointing to the config file, and then we'll do Unix socket. So we're basically, what we're doing here is reloading the config. Okay, so it says empty payload is not allowed. Maybe I have to do capital D. Or maybe the name of the config is different. I'll have to double check in a minute. Failed to open config. Okay, I'm just going to check that directory. Wrong path. Still, it doesn't like it though. Let's try the other one. There we go. Okay, I am going to copy and paste this command for everyone. And try that one. I definitely recommend copying and pasting it in a text editor first, so that you don't get any weird GoTo training characters or something. So it sounds like we're having some weird audio issues. Okay, let me know if that helped. If you guys see if you see that reconfiguration done, you should be able to run the other command that we ran first, and you should see the application and listener object.
Yeah, this is Chris. I still get the same thing. Anybody else having trouble, or is it just me?
Mine was working just by following the steps that are in the guide.
Let me take a look, Chris. I'll take a look at your
Okay,
machine.
I'm student 4.
Okay. Okay, you should be fine now, Chris. Okay, let's go ahead and move on. So again, this is the example output you should see when you run that last API command. Now, the next thing I want you to do is actually test the web application. So you should have a WAF host name. So it should say WAF dash and then basically the EC2 tag name. And then I want you to hit the endpoint setup.php. So if you don't have that, let me know and I can send it to you in the chat window. But it should have been in your email, I believe. So for instance, mine is WAF-R16- and then the date I spun up the machine dash my number, which is the student name, .security.nginxtraining.com. So if I go to setup.php, this is what you should see. Now, basically what we're going to do here is we're going to recreate the database. Luckily, this makes it pretty easy for us. We're basically just going to click this button at the bottom because I've pre-configured everything else to be the way it should be. So once you click that button, it should say setup successful. It will redirect you to a login name. I think the name is admin, and the password is password. Super secure, right? Yes. Okay, but now we're not done. The next thing we're going to do, and the last thing we're going to do really, is we're going to set the security to something insanely low. Because right now it's set to impossible by default. So the next thing we're going to do is we're going to go to this little area here where it says DVWA security, set this little radio or drop down window from impossible to, I forget what it is, easy, it says something. Yeah, low, sorry. So set it to low and then hit submit. Okay, so that's pretty much all we're going to do for now, and then I'll actually start with the content now. So let me know when everyone has that step done, and then we'll move on.
Hi James, this is Genchi. My laptop just crashed and rebooted, so I'll just spend a bit of time catching up.
Okay, thanks for letting me know.
Yes.
Okay, I got a couple messages from people saying that they're good to go. Okay, so luckily,
This is Chris. I'm good.
oh, you're good? Okay. All right. Well, again, just as a reminder, course is 8 hours. We spread it over 2 days. We are going to take a 10-minute break at the top of each hour. This will be a good time for people to ask questions, or if people need to go take a break to get some coffee or use the restroom, that's when we'll do it. Okay, so for the agenda for today, what we're going to cover is, this is somewhat of a retread of basic security best practices. Now, some of this is probably review, especially for the people who are have experience with this stuff already. Basically you, Chris, and you, William. If at any time there's stuff that you want me to glance over, or you say, you know, if I'm going too slow or maybe too fast, feel free to send me a message in the chat or just call me out. So, but what we're going to cover here is just to make sure everyone has a baseline, is we're going to cover encryption, access control, authentication, and security performance best tips. So today is more of a retread of the basics of TLS security and things like that, web security, and we're also going to frame it in the context of Nginx directives. So even if you know this stuff, there might be some gotchas that you never encountered before, or maybe it'll give you some ideas for ways to improve your existing configs. Now, once we get to the end of today, I'll talk about the agenda tomorrow. Tomorrow's class is centered more around the advanced features of Nginx Plus, such as JOT authentication, secure links, and also the WAF, of course. So, any questions before we start? Nope. Okay. All right. So, first part we're going to talk about here is encryption. So what is the objective, or what are the objectives of this section? Well, not only are we going to review the basics of encryption, and I'll try not to spend too much time on that, but we're also going to talk about what are the key directives to understand in the Nginx config. So this will be your SSL directives, your proxy SSL directives. We'll also talk about your ciphers, protocols, and how you can generate certificates and keys and whatnot. And this is a really good segue into what are the key components of web security. We have handshakes, we have keys and certificates. So basically, handshake, that's the authentication of your key exchange between any participants that are in the web transaction. And then your keys are usually long string data that are used to encrypt or decrypt. So the certificates are what are stored on the server or stored in some kind of vault application and is doled out to basically incoming clients who want to authenticate themselves to your server. And encryption and decryption basis, oh, that's actually meant to be oh, okay. I thought there was slide content missing. Sorry. Okay, so encryption and decryption basics. The encryption is basically what we use to scramble the message, and it usually requires what's called a cryptographic algorithm or cipher. I'm not going to go too deep in these today. There are links, by the way, embedded into each of these topics that you see highlighted as yellow. So if you want a deeper dive, or you need to refresh your memory on some basics of that stuff, I linked some good stuff there for you. But today we're just going over the overview. So decryption, so encryption scrambles the message. Decryption, as you can probably guess, unscrambles the message, and it requires a cryptographic key / algorithm as well. So the two basic types of encryption are symmetric and asymmetric. And then with symmetric encryption, this is commonly your 3DES, your AES. They're commonly used in things like IPsec or other types of VPNs. RC4 has seen a wide deployment on wireless networks as pretty much the base encryption used for something like your home network passwords like WEP and WPA. And the reason symmetric encryption has lasted so long is because it's extremely fast and it's relatively low complexity, allows for pretty much easy implementation in hardware. There's some drawbacks though. All participants basically are required to be somewhat pre-configured with the secret in order for, especially in a hardware use case, they need to be pre-configured in order to have the encryption work. Otherwise, you'll have to encrypt them through some external means. Now then you have asymmetric. Asymmetric pretty much differs from symmetric primarily in that two keys are used, one for encryption and one for decryption. I'd say the most common asymmetric algorithm is RSA, which you should be familiar with if you know SSL TLS. And this offers the ability to have both secrecy and key distribution. So compared to symmetric encryption, asymmetric pretty much imposes a high computational penalty. So when we get to talking about how you can tune the SSL handshake and whatnot, that's pretty much what we're talking about here. So it tends to make connections much slower than if you were to not use this form of encryption. But that being said, it isn't typically employed to necessarily protect payload data, but rather to harden and secure the channel over a non-secure a non-secure medium, such as the internet. And it's accomplished pretty much by an exchange of public keys, which we'll talk a little bit about more later. Okay, so put those two encryption methods together, what do we get? Well, we can basically talk about how we're going to encrypt web traffic, which leads us to our next point, which is SSL TLS. So SSL, which stands for Secure Socket Layer, uses a combination of that type of public key and symmetric key encryption. So the symmetric key is much faster, obviously, but the public key provides better authentication techniques. So an SSL TLS session always begins with some kind of exchange of messages called that, as what we were talking about earlier, the handshake. And then the handshake allows the server to basically authenticate itself to the client by using its public key techniques. And this also allows the client and the server to cooperate in the creation of a symmetric key used for something like, if you're using elliptic curves, for example, you're using rapid encryption, decryption. You can also do something like tamper detection during that session that follows. And then we'll talk about how you can improve the speed of the handshake once we get to the directives. So the downside, by the way, of SSL is that it's no longer PCI compliant. So if you have a website that's using credit cards or whatnot, it's just basically, as of June 2018, it's pretty much no longer compliant. So you're supposed to explicitly use TLS. And then, TLS, just as a quick overview, it supersedes SSL because it pretty much evolved largely from SSL. And it provides way more updated and secure encryption algorithms. Okay, so the Nginx marketing team likes to throw this term around a lot, but what does it actually mean? It's pretty much one of the biggest selling point of Nginx, and it's called SSL termination. So remember that high computational penalty I kept talking about? That's pretty much a way to offload that penalty to Nginx rather than have it be absorbed by the applications or the application servers. So basically what we do here is we can do a couple things to improve this. So for example, we can enable keep alive connections to send several requests via one connection. When we get to the directives later, you can actually do session resumption, where you're reusing some of that handshake data or parameters to avoid subsequent handshakes for any concurrent or subsequent connections from the same client. And you can also combine it with HTTP2 and enable multi-threading. And with HTTP2, because it's a text-based format and the message also makes it, at least in theory, a little bit faster.
Hey, James, can you confirm when you're talking about keep alive, are you talking about between the Nginx server and the app server, or the client and the Nginx server?
So we're talking about the client to the client keep alive, basically. So we're talking about client to server. So you can do the same thing for upstream. So if you're proxying, and we'll get to that a little bit later, but let's say you're going to re-encrypt traffic to your upstream, you can follow the same suit by using upstream keep alives, and that'll also improve connections to your upstream, so you don't have to, do the whole 9-step handshake all over again.
Mm-hmm.
Good question, though. Okay, so sessions by themselves are pretty much stored in the SSL session cache when we get there. And just to give you a kind of a teaser, 1 megabyte of a cache can contain up to about 4,000 sessions. So we'll get to that a little bit later, but that's one of the key selling points of this whole technique of SSL termination. So let's take a quick step back about the SSL module. This is pretty much what's required in order to take advantage of any of the SSL directives. If you're using Nginx open source, it's not built by default. So you'll have to, basically, when you're compiling your binary, you'll have to configure this module, unless you're using like a pre-configured binary, like from a package manager. And it does require the OpenSSL library. So if you don't have, or something equivalent, but if you don't have the OpenSSL library, it will yell at you when you're configuring the binary. So yeah, that's the SSL module. And this is kind of to Chris's question. So what we were talking about up to this point was pretty much client to server connections. So that's the SSL directive. Anything with the SSL prefix is referring to the client to server connection. Anything with the proxy SSL prefix to the directive is referring to upstream connections. So the good news here is most of the stuff is the same in terms of configuring client to server from server to app, aside from a few caveats, which we'll get into in just a minute. Okay, so when you're configuring your HTTPS proxy server, it looks like I just got a message from GoToTraining. Can you guys still hear me?
Yep, we can hear you.
Okay.
Yep.
It seems like there was a momentary latency problem on my end. Okay. All right, so configuring HTTPS, the way it works is you enable the SSL directive, the SSL parameter on the listen directive after the port number. There used to be an old way of doing it. So if you're using an older version of Nginx, you might be familiar with this technique where you have, and I'm actually updating the slide real time. So you might see, have you guys seen that before in some example configs where it's SSL on? You guys seen that before? No? Yes?
I haven't.
You're showing the, we don't see your config screen, do we?
Yep.
Oh, no, I see it now. Sorry.
Yeah, I was updating the actual slide, sorry.
No problem.
Yeah, so if you've
Gotcha.
seen this directive, it's actually deprecated now in the latest release. So anytime you need to enable TLS or SSL for a non-default SSL port, such as 443, you still need to define it like you see here. So even if it was, 8080 or something like that, you would need to define it here. So anyway, that's how you configure a server to accept HTTPS requests. And the other thing you need to do, this is just if you were to do basically the basics, the bare bones, you would need to specify the SSL certificate and the SSL certificate key, which as you can see here is the full path. And then in this example, we're using a .crt and a .key file, but this could also be a .pem file, which would include, all your root and intermediate certificates as well. Okay, so the SSL DH param, by default, I just want to let you guys know if you're not aware, Nginx uses a really crappy default that's inherited from OpenSSL. And I think the basic DHE, the ephemeral Diffie-Hellman parameters that are provided by OpenSSL use a lower weak key. So the best thing you should do is actually build your own on a case-by-case basis. So, best practices is to throw, a 4096-bit key at it. If you do it without the ds param flag when you're using the OpenSSL command, I will warn you that it takes a long time to calculate all those primalities, but it'll be worth it in the long run, or you could just simulate some of those primality calculations to make it shorter. But the point here is no matter whether you do the former or the latter, it's going to be way better than the default. So once you're done building those that key, you can basically point to it using the SSL DH param, and then of course the path to that PEM file. And I will do this in an exercise too, just to show you what I mean. Okay, next one, SSL protocols. This is probably the best place to start if you're not familiar with some of the SSL directives. It's kind of a given that you shouldn't be using any SSL versions anymore, especially since Poodle pretty much put the knife in SSL version 3. So what we do here instead is we specify TLS protocols, especially because SSL is no longer PCI compliant. And it's also a best practice to only use the latest TLS version. So this is either going to be 1.2 or 1.3. With the latest release of Nginx, we now have support for the TLS 1.3 ciphers. So definitely recommend putting that in your configs if you haven't updated them already. Speaking of ciphers, probably the hardest thing to get right, and I'm sure, Chris, you can probably attest to this. What's best today may not be so hot tomorrow. And you'll also have this constant battle between high security and compatibility. Or when I mean compatibility, I mean user agent compatibility. So in other words, if you have a million ciphers in there because you're trying to cast a wide net of compatibility, yeah, someone with Internet Explorer 5 can access your site, but do you really want them to is the question. So in the spirit of this course, we're actually going to keep our ciphers pretty minimal, and we're going to use the latest and greatest, basically that's outlined by RFC guidelines and places like WallArm and the consortium. So here, what we're doing is we're using AES and elliptic curve, and we're using the Diffie-Hellman key, and then we're also using the ephemeral Diffie-Hellman key here in the second one, and then we're also disallowing any weak ciphers or empty ciphers. So the good news about using this, other thing I want to point out here is prefer server ciphers. So this prevents downgrade attacks for certain browsers that are either older or they're like places like Chrome or Internet Explorer that are using maybe it's an older version that a client hasn't upgraded and it's using a specific set of ciphers. The prefer server ciphers prevents these kind of downgrade attacks and forces the client to accept the ciphers that you've specified, like we've specified here.
So can you give a little more detail on that? Because it's my understanding that any Nginx or any other web server would always would always be willing to downgrade itself to its minimally supported version if the client so requested. So what exactly does the prefer server ciphers directive do, or whatever do there?
Well, it just ensures that whether the browser ciphers, right, have this.
Mhm.
It just ensures that it has any of these in the list, and it selects them. It kind of pinpoints them and selects them as the one to use. That's pretty much what it says. It says the browser, like you said, it was like the browser, I want to use these ciphers list, and then during TLS negotiation, the server pretty much says, well, we prefer to use these if they're available. So then that's what it's going to do. It's just basically going to select the ones that you've specified only. Now, if it's not there, I'll have to check with the PS team what happens. I don't know the details of what actually happens behind the scenes.
Yeah, I was just curious because with the line above that with the protocols, obviously if the client tries to connect with a version of SSL that is not supported, it'll just be a handshake failure.
Right.
So I'm curious what happens if the client tries to connect with a cipher that is not available. If the client says the strongest cipher that I have available is a cipher that the server doesn't support, then what exactly happens, and how does the prefer server ciphers option there affect that?
Okay. Yeah. So let me ask the professional services team, and they'll probably get back to me in like 20 minutes.
Okay, cool.
Because I've actually never tested this myself. It just always, it's like Apple. It just always works. But you're right. We really should know what's happening, at least in the error log and access log and whatnot, if something were to go wrong. So yeah, good question. All right. What was I going to talk about next? So that's SSL ciphers. So this isn't necessarily Nginx, of course. This is just pretty much standard web headers, response headers that you can add to Nginx to ensure that you're forcing the client to communicate over HTTPS. And then you have other headers too. So if you want to prevent MIME type sniffing from the client, or you also want to prevent clickjacking and things like that, you can add these specific headers. So X content type options, X frame options deny, and those two prevent specifically MIME sniffing and also clickjacking. Nginx also has the ability to what we call stack RSA and ECC certificates. So depending on what happens during TLS negotiation, if the browser can accept something like elliptic curve, and we'll have lightning fast encryption, it will use that certificate, or it will send that certificate to the client. If it's like an older version, for example, and it only supports, I don't know, let's say it's an older version of an older browser or an older TLS cipher suite, you'll send an older type ticket like RSA. So the way it works is you basically just include both pairs in your configuration file, and also the path to each of those certificate chains as well. And then Nginx will basically figure out upon the handshake which one to send to the client. And speaking of elliptic curves, just like Diffie-Hellman, elliptic curves, Nginx doesn't inherit a good default from OpenSSL, so it's a good idea to specify one manually. I am not an elliptic curve expert. I'm not going to pretend to be, but this is the one that I've researched and works pretty well. It gives me a really good score when I do my security tests on either OpenSSL or SSL Labs. But if you know better ones, feel free to specify them manually. The point of this directive really is so that you're forcing Nginx to use a good default curve. Because what it inherits from, I forget what it inherits from default, I have to look it up, but it does pretty much lower your security score, and it gives you a little bit more vulnerability if you don't change this. Okay, so while you guys are doing this lab, I'll go ahead and ask professional services the question about the prefer server ciphers. But the first thing we're going to do is we're going to use Certbot, which is a free way to generate certificates. And it's pretty awesome if you've never used it before. What we're going to do is we're going to run the certbot command within the WAF host. So WAF host, I recommend creating this bash variable, and this bash variable will be your DNS name. And the DNS name is not your EC2 name, it's actually your WAF-R16- the date - your student number, and then security.nginxtraining.com. So that's what we're going to register with Certbot. And you're also going to register unsafely without email because we don't want them spamming you. And then when you get the option, it's going to prompt you for certbot to modify your configs. If it does, feel free. Or well, you're going to select no first. But if it does modify them somehow, you're going to have to delete anything in the config that says managed by certbot. Once you're there, go ahead and open the SSL configs directory with the sslparams.conf file, and then you're going to edit the blank. I think it's blank, or whatever the placeholder is here. You're going to insert your WAF hostname here into all three of these directives that you see here. Then save and exit the file, and then we'll continue there. So I'll let you guys do this on your own, let you struggle a little bit, and then after a couple of minutes, I'll jump in and you guys can follow along with me.
So I got an error the first time. It's saying that policy forbids them to issue a certificate of that name. And let me make sure my host, yeah, I mean, my environment variable is set. It's almost like the command didn't pass my WAF host variable to Let's Encrypt.
Okay, let's, it could have been the way we were passing the variable string. Might be better just to type it out.
Oh, I typed it. I may have fat fingered something.
Okay, let me try it myself.
Okay.
Yeah, because when I used to run this course in the past, we were able to use EC2 host names, but obviously those are blacklisted now for good reason. So let's see.
That's what's in the variable though, right? The EC2 host.
Oh no, it should be this. Here, I'll show you. It's actually.
Oh, did I miss?
Yeah, and you know what? I haven't seen the emails that went out. Maybe they were incorrect. Let me take a look at mine actually.
Well, I just set the WAF host variable like a few minutes ago as we were starting class. I thought that's what we were supposed to do.
Yeah, you were. So let's do. Yeah, it should look something like that. Does that look like what you have?
No, I'm using the EC2 host name.
So I think in the email it's the DNS name.
Okay, let me find that.
Echo.
Oh yeah, I see now. Okay.
Okay. Yeah, I encountered that the hard way, and it makes sense because they don't want you to pretend you're Amazon.
Right.
That'd be hilarious if I could do that. Okay, where was I? All right, so yeah, I'll go ahead and do the lab with you guys now. So let's do sudo certbot nginx -d WAF host. Okay.
Got one more error. Let's see if you get it.
Could be the way I'm the way the certbot command parses the string, maybe. Is this the error you got up here?
Yep.
Unable. Yeah, this is okay. So that's actually good because then it's going to force us to do it ourselves so we can learn. And plus, we don't want certbot taking control of our Nginx configs. So, okay. So basically what we're going to do now is the step 3 in lab 1. So if we go to etc nginx SSL configs, SSL params, So I think there's a file there called SSL params. Oh, I'm in CD, of course it's not going to show me. Okay, there we go. So we do sudo vim SSL params. And yeah, so what we're going to do here, you can see there's some stuff commented out. And I've already pre-configured some stuff for you already. So SSL stapling, SSL verify, which we'll talk about later. We have SSL protocols. I have my preferred ciphers. No cipher suite now. So if you were to try to reload, it would yell at you. But let's copy and paste those first 3 directives at the top here. So it's going to look like this. And of course, we're going to basically put in our WAF hostname here. Now, unfortunately, the config, at least to my knowledge, doesn't take bash variables. If you were using something like Docker or Kubernetes, you could use a Docker environment variable, which is probably better. But if it's a true cloud server, you have to type it in, at least to my knowledge. Okay, so that looks good.
So you want us to leave the ciphers alone for now?
For now, yeah. I think in the next lab we add it there. Yeah. So if I were to try to reload, for example, it would say, "Hey, what the heck's this cipher suite thing?" How's everyone else doing? They caught up for the most part?
This is Chris. I see the full chain and the private key file, but I don't see the third one, the chain.pem.
You mean in your where the encryption is located? You mean? Or I mean where the keys and certificates?
No, the messages that came back from Let's Encrypt.
Oh yeah. So if you actually go to this directory here, you'll find it. It's actually.
Oh, it's in that. Okay.
Yeah.
It's not echoed out then. Okay.
Right.
Gotcha.
And I forget why. I'll have to check certbot's documentation why the chain.pem needs to be here instead of full chain. I think they would both work, to be honest, because full chain would just have all the root and intermediate certificates. There's a reason why. I can look it up during the break. But I've noticed that you get a better score or less SSL errors when it says chain.pem. Okay, so it sounds like everyone's good. Let's go to the next step. So now we actually need to configure some stuff because right now our server doesn't actually listen on port 443 yet. So what are we gonna do? We're gonna open up our dvwa.conf. This is for the web, the dvwa.app. We're gonna change the server name to your WAF hostname. And we're going to add a return directive that forces all traffic to HTTPS. So I have an example of what mine would look like right here. And actually, I could probably, no, I can't copy this because the date's different. But this is essentially what you want for your 80 block. So if I go back to my config, you're going to go to up one level, take ls. You can see we have some files in here already. So in DVWA, we have a bunch of stuff already. This is how so we've already configured it to listen on an upstream. We have a root index, all that nice stuff. But what I'm going to do here is, it looks like my tabs are off. Hold on, that's going to bug me. Does that bug you guys? It bugs me. Okay. Okay, perfect. Okay, so what I'm going to do is at the root directive, I'm just going to return here really quickly and close this server block. I'm going to change this server name to my WAF host name, or the DNS name rather. I should probably get my verbiage right. And the last thing we're going to do is add that return directive. So the return, if you're not familiar or you've I haven't touched it in a while. We're going to force a return to, or a redirect to a different URL, or in this case, it's just a different port, really. And we're going to force the 301 return code to the client browser so it doesn't, indirectly cache it. So what we're going to do here is use force HTTPS, and then we're going to take the host that was entered in the browser, and any arguments and URIs that follow. Okay. Next, we're going to add another server. And as you could probably guess, we're going to add this as an SSL server. And we can also add the server name as well if we want. And finally, we are going to include the config that we just edited. So that would be etc nginx SSL configs SSL params.conf. So that way you don't have to actually put everything in your server context here.
Oh, you're
There
back.
you are.
We lost you for about 30 seconds there.
Oh, really?
Yeah, we lost you when you started opening up that second server block.
Okay, sorry. So basically what I did is I added port 443. Can you guys still see my screen though?
Yep.
Okay.
Yes.
I added a server name with the host name again. One thing you also might want to do, and this is just a best practice, is to set a default server. So you're like, this is the default HTTPS server, for example. Then we have our server name, which matches up here. So any HTTP request that matches this host name is going to go here, and any HTTPS request name that matches our host name is going to go here. And then we've included the configuration that we just edited here with this include directive. Looks like we have a message in the chat. Okay. So while you guys catch up and do that, I'll show you the next step in the lab, and this should be the final step, I believe. So the last thing we need to do is, actually there's two more steps. So the last thing we need to do is, if you're not familiar with how Nginx works with regards to proxy and connections, the way it works is it terminates not only, if we're talking about SSL termination, it also terminates the initial TCP connection by default. So that's why we need to add things like proxy set header if you want to retain that information so that the upstreams can know where the origin was. So for example, xreal IP, remote address, if it'll build a list of any proxies that it was filtered through, that the request filtered through, for example. So we're going to add those to the config as well. So I will add them here. And in the final step we're going to do, as you're probably going to guess, is we're going to fix the ciphers list. So if you check lab step 1.3, you can actually check the versions of the cryptographic algorithms that are supported in the cipher list, as you see in step 1. But in step 2, you're basically going to reopen SSL params and then place the ciphers in the cipher directive. So if I show you really quickly, and then we can go ahead and take our first break. Okay, so this is what it's going to look like. And if I exit this file really quickly, SSL params, and then I go down here, I'm just going to delete that line and paste it there. And that's it. After we save and reload, our configuration should work, in theory. Yep. And you can always test it by doing a curl-k https localhost. You can also do -i too, see if it worked. It says it's found, but it's because it's an application. So the best place to actually check this is probably in the browser. So if we go back to my web application here and I hit a refresh, watch what happens. Boom. It says it's secure now. I don't know why it's not green though. Well, it says it's secure. Maybe it's a new version of Chrome or something. Anyway. Okay, so that's working. I will leave my config up for anyone who needs to read it. And let's go ahead and take our first 10-minute break. So let me make this a little smaller.
Hey, question before
Sure.
break. Hold on. Pull this file back up. So with any formally recognized headers, some of the really common ones, for example, exported for, like you have listed here, is the the actual variable that you're using to populate that header. Is there a list of those? Because for example, x-4 is published and that's globally recognized, but I wouldn't have known to use $proxy _add_x, as the variable. Is that listed anywhere?
Yeah, it's in the it's kind of verbose, but it's in the official Nginx documentation.
Okay.
It's basically added. I know it's not the easiest to read, but it gives you, when you look at the full list of the variables and you click on each one, it shows you what use case they're used for, and then this one says specifically it's used for this one.
Right.
But yeah, if you were trying to look up what's the recommended practice for the known header, right?
Yeah.
It wouldn't have. It would say you can either add them in yourself or use the embedded variable.
And I guess even broader than just this particular directive. So if I wanted to use the client IP, or that's remote IP, I guess. If I wanted to use the destination IP to populate some kind of directive, is that destination _ADDR, or is that something else?
It's upstream.
And where do I find that?
It's upstream _ADDR. But again, that's in the variable list. Let me see if I can pull it up. So it's probably.
Yeah, I think that would be helpful for the rest of the class if you could find that list.
Yeah, let me look. Yeah, so this is it right here. Let me drag it. I just pulled it up in a different window. So this is it here.
Okay, perfect.
And there's I think there's 900 of them or something.
Right. Would you mind linking that in chat?
Sure. Also, if you have any questions about use case, even after class ends and you want to shoot me an email, I can track down someone who either has the answer or I can answer it myself. For example, GeoIP, you can probably guess what this is for. It's for geographic IP and stuff you want to do there. If you have the MaxMind database, for example, and you have continent code, country code. But some of these are a little bit nebulous, right? So you look at, let's find one that you can't really. Yeah, what the heck does modern browser mean, right? It's like
IE6.
I guess so. Anyway. Oh, this is a good one, actually. This one solved a lot of problems. I know we're kind of going off book now, but the request ID was generated in the last release, I believe. But it was a randomly generated hexadecimal that you can attach to a client response URI or a client request URI if it was going to an application. And it was a really good way to perform application server-side logic or even proxy server-side
correlation.
Yep, exactly. I can't imagine why they didn't have that earlier. But anyway.
You said that's new with a recent version?
Yeah, 2 or 3 releases ago, I believe. Okay. And it's open source, so you should have access to it. Actually, let me confirm that really quickly. Yes. Otherwise, it would tell you right here. Okay, let's take our first 10-minute.
I'm here.
Okay.
Bill's here.
All right. Do you prefer Bill or William?
Bill preferred. Thank you.
Okay. Call him Billy.
Call him Billy.
Thank you. Thank you.
All right. Noted. Okay, Shigeya is back. I'm going to give everyone maybe 1 more minute, and then we'll get started. By the way, last lab, I forgot the last step, which was actually testing it to see your cool score on SSL Labs. So feel free to do that if you want. Basically, the way it works, if you've never done it before, and this is just one option for testing your SSL or your security, rather, on your site. There's internal crawlers I think you can download too. But you basically just copy your host name here without a protocol. And you go to server test. Probably don't want to show it on any boards. And then you hit submit. Okay, so while we wait for that, let's go ahead and get started. I'll come back to this in just a minute. Okay, so
I'm back.
Okay, cool. Everyone's back. Okay, so we basically secured client traffic, but what about upstream traffic? So again, by default, Nginx will establish a new TCP connection to an upstream, and then it will terminate the client TCP connection. So what Proxy SSL does is it will re-encrypt traffic to the upstream server after the SSL termination takes place. So it doesn't necessarily mean the traffic also has to be decrypted, by the way, either. But Nginx does have to pass a certificate that's signed from a trusted authority in order to avoid some kind of SSL rejection. Now, there are ways. I get a lot of questions about how to do this with like self-signed certificates. And there are ways to do it, especially if you're going to do something like MTLS. That's a little bit out of scope for today. But if you're interested in MTLS, by the way, ping me during the break, and I'll see if I can track down some documentation that's kind of in the works. But anyway, so with self-signed certificates, we'll get to it a little bit later, but basically each participant in the transaction kind of has to be their own CA, but then you'll run into other problems of like, okay, so but does that mean each one has to exchange private keys? Because that's dangerous. So anyway, we'll talk about that a little bit later. But in general, the way it works is Proxy SSL encrypts traffic to upstreams. Proxy SSL certificate and the key are used to authenticate. And then the client has to be signed, or the certificate has to be signed and trusted by a CA. So someone like Let's Encrypt would work. Okay, so you've heard the term end-to-end encryption. Well, it's not like SSL pass-through. That would have to be layer 4, which you see in the second bullet. But with layer 7, again, you can decrypt and re-encrypt, or you can just re-encrypt without actually decrypting. And that's what the SSL and Proxy SSL modules achieve in terms of layer 7 traffic. So with layer 4 traffic, we're not going to talk about TCP too much today, but with the SSL pre-read directive, and I've linked to the documentation for it there at the bottom, it relies on the server name indication field. So that's how it uses that header, if it exists or configured, to pass that connection via TCP connection to the actual application itself without actually having to read or decrypt the SSL or the TLS packet, rather. Okay, well, I thought I wasn't covering it, but apparently I am. So with this new protocol, yeah, go ahead. Question?
No, just chat. Laughing along, sorry.
Yeah. Yeah, I'm glad we can make this humorous. Anyway.
I think your screen may have frozen again.
Do you see SSL pre-read variable?
Oh, never mind. It's good. It's good.
Yeah, we're good.
Same else.
Yeah, we should all send an angry letter to go-to training for their dumb refresh rate or something. I don't know. Anyway, so SSL pre-read protocol basically allows you to, as you can guess, distinguish SSL and TLS protocols when you're forwarding your traffic to some other application that's able to accept TLS or HTTPS requests over TCP. So the variable itself, the $SSL _pre-read protocol, contains the highest TLS or SSL protocol version that's supported by the client. And this is also kind of useful if you want to avoid firewall restrictions. So for example, running SSL, TLS, and SSH services on the same port. This is one way to kind of sidestep that. But the main use case is pretty much if you're basically running SSL and non-SSL protocols over the same port. And also when you terminate and decrypt SSL or TLS transactions, the SSL protocol variable captures the version of SSL and TLS used by the client. So you can also use this for layer 7, by the way, if you want to store some of those variables and then proxy them over. But it's very useful with TCP by not having to decrypt and just pass it through. So this is a good template to use, by the way. So what's happening here is stream, by the way, TCP context. We have some kind of, it looks like this is for SSH. We have a map directive that's basically reading the SSL pre-read protocol. So again, this is the SNI field. And it's saying, excuse me, if it has TLS version 1.2 in the cipher suite, or supported cipher suite, you're going to go to what's called web, which looks like an arbitrary name for this. Yeah, that's a different upstream that's not listed here. But all default SSL protocols are going to go SSH. So that's essentially what's happening here in the upstream, and then you're proxying to that upstream. Actually, yeah, if this were a complete example, it would look something like this. So you'd have upstream, web, and then some server in there with a different port. Anyway. Okay, so I promised I'd talk to you about this, self-signed certificate tips. Make sure you own the certificate authority. So if you've created applications or some kind of repository behind your firewall or a centralized location that acts as your CA, this can be very useful. You're going to use the Proxy SSL Trusted Certificate Directive, and the file has to be in PIM format. Now, you also may, if you don't own a CA, you may need to disable the Proxy SSL Verify and also the Proxy SSL Verify Depth, so that it doesn't actually go through the root and intermediate chains to validate to see if they match the private key. So yeah, but if you are using a certificate authority, I definitely recommend to enable those directives just for added extra security. So that's what they do. So Proxy SSL Verify verifies it's from a trusted authority. Proxy SSL Verify Depth, it goes how deep into the chain, how many layers that it's going to basically do a check against. Also, if you've ever seen this infamous page, 502 bad gateway, most likely it's caused by this issue. I would bet money when I talk to support that whenever they get a 502 bad gateway from like a client or a partner, when they're doing their troubleshooting or debugging, the consistent problem is you're using self-signed certificates and you're trying to proxy a HTTPS connection after the initial client connection terminates, and there's some kind of handshake error. So again, it's hard, but it's doable as long as you follow those two principles. So your upstream also has self-signed certificates, and you also own the CA. You own the CA that's on the back end. Okay. And by the way, MTLS kind of takes care of that problem in an intelligent way. So if you're curious about MTLS, we don't talk about it today, but send me an email and remind me, and I can send you like a Google Doc or a write-up that will talk about it in detail. Okay, so subfilter directive. So the primary use case for the subfilter directive is to pretty much handle scenarios where, let's say the backend application server is returning pages with absolute URLs rather than relative URIs. So from a security standpoint, there's also the added benefit of hiding the backend hostname if that's something that you care about. For example, WordPress, maybe the backend WordPress is like an IP address, or it's an EC2 hostname, and you want to hide that or rewrite it so that it doesn't appear in the client name. But really, it's mainly for mixed content errors and things like that. So basically, serving HTTP responses when it's expecting an HTTPS response. And that's all I'm going to say about that. Okay, so next lab we're going to do, and then we'll go into our next section. So we're going to secure our upstream traffic now. So I want you to open up the API server.conf. It's not actually like a conch server or anything. It's just some configuration I made that returns string messages. But we're just going to suspend disbelief for a moment and pretend that it's an actual API server. So what we're going to do with that is we're going to turn on SSL in the server context for API server.conf. You're going to create a location / then add a proxy pass to the API server, and then pass the actual full chain that you generated earlier. You're also going to turn off Proxy SSL Verify. You could leave it on if you wanted to because it's signed by a CA, but I'm just lazy, so I decided to turn it off. And then you can also exit the file, reload Nginx, and then test that endpoint, basically the API server.conf, using localhost 8080. You should receive some kind of error. I think it's 502 bad gateway, and then we'll fix it in the next lab step. Okay, so let's go ahead and do this together. Hopefully I don't have a broken pipe. Yes. Okay, so if you're already in conf.d, you can pretty much just open up dvwa.conf. Not dvwa.conf, the other one, apiserver.conf. Here you see we have two upstream servers listed on 8081 and 8082. We have the old configuration here actually, so we're going to delete that for now. And you see we also have an include directive here, so we have SSL configs, SSL params.conf, and then we have two servers down here. So what we're going to do is add SSL to this listen parameter, or listen directive rather. Come on, insert mode. There we go. Okay. And we actually don't need to include anything here because it's already in our file. But we're going to add the location anyway. So we're going to do location. And then we're going to do proxy pass, HTTPS, apiserver.conf, or sorry, API server. And then we're going to do proxy SSL trusted certificate. And it's going to be Etsy. Let's encrypt live, and then your host name, or sorry, your DNS name. Let me see. I gotta grab mine really quickly. And then the next path is the full chain dot. And again, we're going to turn off proxy SSL verify. Okay. So once I reload this, I should get a 502 bad gateway. And oh, that makes sense. So I forgot to close the location. Cleaning this up a little bit. Okay. So we reload, everything looks fine. No errors. However, when I curl the HTTPS server, I get a 502 bad gateway. So does anyone have a guess as to why?
Is it a self-signed certificate problem?
Actually, that was my first guess too, but it is not. It is actually much simpler than that. So if we look at the error log, so
I'm actually not getting a. I'm actually not getting a 502.
Oh, did you?
I don't know what I did.
Let me see. Maybe yours is working magically. Let's try this. No, I'm still getting it, even with the verify on.
I used 443 instead of 8080, but that shouldn't matter.
Oh, now you're probably getting port crowding though, because you have the other config that's also listening on 443.
Yeah, cool. Okay.
That was why I used that 8080. Okay, so the reason we're getting the bad gateway, I'm not going to, well, I probably should just so you guys can see the troubleshooting process. So I'll configure a quick, oh, I did configure an error log. Okay. I thought I didn't. Okay, so if I go to sudo tail, I'm getting a little latency, guys, sorry. Tail-f var log nginx API server.error.log. You can see it's an upstream problem. So it's not necessarily our server config. It says upstream server temporarily disabled while SSL handshaking to the upstream. It says client localhost server request get upstream. And it says, what's it say? Handshake failed. And the reason why is because the upstream isn't configured to accept SSL. Pretty much what's happening. So if we go back, to our API server. The upstreams are down here. And take a look at this. These are HTTP servers. So how do we fix it? Pretty simple. SSL, and then you need to include the parameters again. Now, because it's over localhost, we can reuse some of this information. So we can include etc nginx SSL configs SSL params.conf. Include etc nginx SSL configs SSL params.conf. So for the internal Nginx folks, this is something to remember when you're dealing with clients and trying to troubleshoot their problems. If they get a 502 bad gateway, this is the first thing to check. check for handshake errors. Okay, so when we curl it, boom, it's working. And it's just using round robin load balancing here. Okay, so let me show you all my config. I kind of sped through the lab steps a little bit, but that's essentially what we needed to do to get it to work. So let me make this a little smaller. Okay. On lab 1.7.1 also has the full example as well, I believe. Another thing we didn't do is we didn't include the proxy SSL params.conf. So if you want to, that's optional, but if you want to take a look at that configuration, which also exists in this directory here, it will give you specific proxy SSL directives for the HTTPS request that you're sending to the upstream. And you'll see it's pretty similar to the other configuration. Okay, so did everyone get theirs working? Have any questions?
Yeah, mine is working.
Okay, cool.
Just observing. Is it really doing round robin or is it doing something else?
Yeah, it's doing weighted round robin.
Weighted. Okay.
Each of these servers, if you go to this file here, it's just the HTML file that says this is app 1, this is app 2.
Yeah.
You might get that weirdness sometimes with the right after a reload, and I've noticed this with Nginx, and I don't know why. After you reload after you reload Nginx, the first 2 connections to the upstream are like from the same server or from random servers, and then it will cycle. It will fall back to the weighted round robin. So I've asked support about that, and they're like, yeah, we don't know. They're like, you have to ask the engineers and check your error logs. That's what they always say. Anyway, okay, so sounds like everyone's okay. No one's really complained yet. So next step, and I believe this is the last step, is we're going to set up an API dashboard and then gather some metrics so we can view it in a browser. So feel free to just copy this as is. It should work. And put it in your API server. So if we go here, location/API, dashboard, HTML. You also may want to add a zone directive so we can gather metrics for our server here. Actually, before I do that, I'll reload and show you what happens if we don't do that. By the way, this is Nginx Plus only features, so I forgot to ask if you guys are running open source or Nginx Plus. So if this doesn't apply to you, I apologize, but it might be cool.
Bill, do you know? I honestly don't. So Bill and I are both fairly new to the company, and we don't have a lot of experience specifically working with Nginx web servers. I don't remember if we're running Plus or open source. Do you know, Bill?
I believe we're running Plus.
Oh, okay, great. Cool. So you guys, this will apply to you then. Awesome. Let's see what I did wrong. Oh, I think I forgot to reload maybe? Yeah, it failed. What did I forget? access log off. Oh, extra semicolon there. So it didn't actually reload it into memory is what happened. So if you guys are fairly new to Nginx, are you guys aware of how the reload works?
Intuitively, I would assume it works like most other configuration file reloads, but no.
So it essentially, like rather than using system control or the service directive in Linux, you can use Nginx-S reload, which essentially sends a sci-hub to the kernel. And what it does is the master process of Nginx reevaluates the config for any changes you made. And if the config's passed a test, it basically forks new worker processes, which are actually handling the HTTP or TCP connections, while the old ones gracefully shut down. So the point of it is it will check for emergency level errors, and it won't reload the config into memory like you saw there. So that way you get no dropped connections even when you're trying to make changes.
Nice. Yeah, I remember the last training mentioned that.
Oh, okay, cool. And you can do this via API too.
But would you ever run into issues with like long-lived connections that refuse to die?
Absolutely. So that's one of the biggest weaknesses is like a blocked thread. So maybe it's a long-lived connection, and that worker just stays alive even after you've reloaded. Yeah, I forgot what you have to do in that situation. I think you actually have to kill Nginx, but I think there is
turn the server off.
Yeah, just turn it on and off and on. No, there is a workaround. What's called a thread pool directive, which could, you could bit mask a CPU core so that it always handles a certain kind of long-lived process, and then it won't be affected by the Nginx reloads. But that's pretty advanced. If you're curious about that, I would need to forward that to the professional services team, or I could just give you documentation.
No, don't worry about it. Just kind of curious.
Yeah.
I feel like I missed. You did one thing at the end here before you ran that curl. What was it that you changed?
Right. So if you copied from the slides, there's a typo. There was an extra semicolon right here.
Oh, I typed it.
Okay, so you should be fine. And I did that on purpose to show you the error. Just kidding. Okay, so here we don't really see much, right? And if you've ever used open source, you might be familiar with some of these metrics. It's pretty much the stub status module. And we get a lot of flack from this because people are like, have you ever seen that article online when it's like, why would you ever run Nginx as a load balancer? And the reason why is because they're complaining about this. But with Nginx Plus, they're complaining about the metrics because stub status only shows, I think, this over here, and that's it. Whereas something like HA Proxy shows a lot more for its open source version. So what we need to do here is we actually need to add in some shared memory zones so that we can see some metrics. So we can call this API, and what this does is it segments the memory and it stores the counter information as well as like detailed connection information. And we can define a size of 64 kilobytes. So this is the default that's recommended by the support team. Depending on what kind of traffic you're encountering, or depending on how many servers you have in your upstream, you may want to bump it up to 128, but it's pretty much, it's like byte information, so in text-based, so it's not really that big in terms of consuming your memory. So just a FYI. Also, if you run out of memory, it'll just say exhausted memory, and it'll serve 503. I think it's 503. And you can always, create more shared memory zones. So a status zone.
I do wrong. Why is my dashboard not showing up? I didn't specify the port.
Oh, that might be why.
Yeah. Okay, it's good. Thanks.
Okay, so here we have status zone API gateway, and then down here I'm going to create another status zone in these servers. And status zone is if you want to get either individual metrics or you want to aggregate them, so we could call this status zone APAC, right? And then this one would be status zone EMEA. Did I spell EMEA right? No, it's duh. Is it MEEA, guys? I forget.
Europe, Middle East, and Africa.
Yes.
So yeah, I think that's right.
That's the best way to remember it. See, I always remember it by making it up like with food names. I'm like, eggs,
Yeah,
maple
yeah.
syrup. Just kidding. All right. Cool. So now we got 3 server zones. And oh, you may be wondering what this 400 code is. So this is the cool thing about the dashboard. It'll tell you what kind of error responses you're getting or responses in general. It will show you bytes received and sent. It will show the requests. And of course, it's aggregating them. So if I were to do this, let's just comment this out for a minute and do APAC. It's going to aggregate them all in one place. And then the upstreams themselves are the actual server information. So we get the requests, response, connection traffic. If you have a limit rate assigned, it'll show up here. Yeah, server checks. We haven't set up a active health check yet, and then other health monitors as well.
So let me ask this: we have a somewhat commercial off-the-shelf solution that is entirely built on top of Nginx, deployed in our environment today. It's our customer-facing kind of identity layer, gateway layer, and I don't think that we have the dashboard. We're not using the dashboard today. What I'm wondering is if I were to go into one of our non-prod environments and just add that additional location, would I all of a sudden have a dashboard, or is there other stuff that I have to turn on first?
Nope. If you have Nginx Plus and you pretty much just copy and paste, aside from my typo, if you copy and paste that in your config, you would pretty much have a dashboard.
So before I enable that dashboard, I guess I'm concerned about performance. This public-facing site receives, I don't even know. I mean, I'm guessing tens of thousands of requests, maybe more per day, hundreds of thousands. What kinds of overhead do you see with the dashboard?
I've actually never encountered that question before, oddly enough. Because we've never had issues with it from any customers when they deploy it. And we're talking about customers like yourself who are enterprise and they're just receiving millions of requests, a week, right?
Right.
Yeah.
So I wonder if you don't have it on, is there actually any new information being saved to disk or to memory when you enable it? Or is it already doing that and the dashboard is just presenting it?
Yeah, this is Chris. So it's in memory, so it's automatically updating all these values anyway.
So by including the dashboard location, it's not like I'm enabling new functionality. It's just giving me visibility into what's already being done.
Yes, and there is some memory consumption, obviously, when you do these zones that he just created, because you're allocating a portion of memory to collect the what you would call the aggregate statistics for these zone groups, right? So you are allocating a little bit of memory for that, but the base statistics are already there. Are you concerned about the overhead on the server, or are you concerned about remote access to the dashboard?
Well, we would want to eliminate remote access, but that's not where my head was. I was primarily thinking, we have six edge Nginx servers that are acting as reverse proxies today with some third-party software running on top of them. And I'd love to have this kind of visibility into incoming traffic, but I'm concerned about what will happen if I just go flip on this dashboard. Will there all of a sudden be an additional load on these servers?
Yeah, well, I wouldn't advocate just flipping it on in production and seeing what happens.
After proper planning and testing.
I would say, stand up another server and run some performance tests, and then, see what you think.
Sure.
But the UI is that's kind of formatting this page and creating that's extremely lightweight as well, right?
Yeah, you don't even actually need the page if you want to look at the statistics. You would still need to, again, define those shared memory zones to collect and store the metrics somewhere, but you could also just parse the JSON and put it somewhere else, right? Like you could take the raw JSON and give it to Datadog or whatever other dashboard solution you're going to use. This is just nicer because for multiple reasons, right? You can, if you enable the API, you can edit it through this dashboard GUI, and make some changes on the fly, or you could do it programmatically and see it reflected here. So, and also if you're going to use some of our other products like Controller, this is pretty nice to kind of get a bird's eye of what's happening with your Nginx Plus instances. Anyway,
Cool.
Did that answer your question, more or less?
Yeah, it did. I'm gonna go flip it on and not tell anybody and just hope for the best.
Yeah, and then you're gonna blame Nginx because they told you to do it.
Exactly.
Yeah, that's smart man. But you did bring up a good point about external remote access, and as you can see, this is entirely open to the public as it is now. So after you've created your memory zones, the next thing you may want to do is set up some logging, right? So that makes sense. But then the last thing you may want to do is use an allow and deny directive, which we'll talk about in the next section. But we set up logging here. This is kind of optional. I think we can skip this for now. But I basically set up my own custom log format here because I wanted to see some of these variables that I was specifying in the proxy set header directive. But I think we can skip that because I think we're running a little short on time. Yeah, it's really just to see a different format. Okay, so with access control, that's where we're going to talk about rate limiting. We'll talk about whitelisting and blacklisting, and it'll segue into our next section after this, which will be talking about authentication and things like that. Okay, so first thing we're going to talk about is rate limiting. So we're going to set the limit rate conditions. Then we're going to talk about audit logs, or auditing logs, and debugging log connections, and then how we can use some of the new features of Nginx to whitelist and blacklist IPs dynamically. Okay, so here we have the limit rates. Limitations can be based on the number of connections. So the way it calculates the number of connections is usually based on some kind of key value, usually a client IP address or a server host name. The second will be the rate of requests. This can be it also uses a key to determine when to apply the rate limit, and it can be processed in a per second, per minute, et cetera, et cetera. And the last one is download speeds. So if you have a media server use case or video streaming or whatnot, you have the ability to actually throttle download speeds in certain situations. So with limiting connections, it's pretty common to limit the value or rate limit based on a client IP address. So this is what we're actually going to use in the next example to serve as our key for applying the limit rate or the rate limit. In this case, the variable would be either remote underscore address, which is the octet form of the client IP, or you would have binary underscore remote underscore address, which would be the byte form. So I get a lot of questions, why would I use one over the other? So the remote address can be anywhere from like 16 bytes or even larger sometimes in the octet form. Whereas with the binary remote address, no matter what even if it's a gateway or a CIDR block, I believe it should relegate itself to about 4 bytes. And Chris Acker, correct me if I'm wrong, but I believe that's the main reason why people use it, just because it's a little bit less overhead.
I believe that's true, yeah.
Yeah. Okay, so anyway, so that's where you would define it. You would define it here. You would define the name and as well as the shared memory zone size. Now the limit con directive is where you would actually use the limit rate. So we've defined, here's an example here. So we defined our rate limit for our connections to the binary remote address. We named the zone something called IP, and then we also set it to 10 megabytes. Down here in this location called /download, we've pretty much throttled the amount of connections per zone, per client, to 5. Now, obviously, that's pretty low. This is something you'll have to do your performance testing on. But if you had this set to maybe 100 megabytes or 1,000, You can bump this up to something like 50 or 500, etc. Why you would want 50, 500 concurrent connections from one client, I don't know, but that's up to you to decide. Now the next one is you're going to rate limit based on the request rate. So this is really, oh, excuse you.
Sorry.
So this is really important when we're talking about distributed denial of services attack or denial of service attack. So this is one safeguard for that kind of attack vector. And in this example, you can do something like use the host name that's in the request line as the key. Then you define the zone, same fashion, name it something unique or identifiable, and you specify the name of the zone as well as the request rate per second. And then you have the limit request. So limit request is the same syntax pretty much as the last directive. The difference being here is instead of just specifying the size, we also have to specify the rate per second or per minute, etc. You also have some extra parameters when we talk about the limit request directive, which is basically where you want to apply the rate limit. So we have the zone equals 10, which matches here, and we have this burst parameter, which is 15. So the reason why we have a burst parameter, I get this question a lot. So first they ask, what is the burst parameter? Well, the answer to that is it's basically, it's a queue that you can define for additional requests once the rate limit's already been exceeded. So a lot of people ask, why not just make your request rate 15? Why do we need to queue an additional 15? And the answer is sometimes there's a delay. Let's say if you imagine concurrency, and there's multiple clients trying to hit your site, rather than have the 11th request be served a 503 code immediately, right? So that client's going to get a 503 code. You can queue a certain amount of requests so that certain clients, just because they missed that threshold by a millisecond or two, aren't going to receive an error code, right? So that's pretty much the use case for burst. The other option is no delay. If you really don't care at all, and you're going to say, tough luck, then you can also put no delay here as well. So, okay, what was the next one? Next one is download rate. So with limit rate, basically this is for download speeds. You can apply it to, another thing I didn't mention. So you can use these in conjunction, as you could probably guess, you can use a lot of these rate limit directives in conjunction with one another, and it's also recommended to do that too. Now it's applied to each connection. So if we're using it in conjunction with the limit con directive, for example, for every 5 connections, each 5 has a download speed of 50 kilobytes per second. So here, the speed is defined in bytes per second. So it's 50K here, and then if you wanted to do something a little different, like let's go back to the video streaming use case. So let's say you're Netflix or someone equivalent, and you're serving large files over the network, and you want the client to have a decent viewing experience. You can use what's called the limit rate after. So the limit rate after is basically saying, yes, we're going to throttle download speeds, but only after the client's built a significant buffer. So this is really, again, useful if you're using video streaming technology or video on demand or something like that, and you want to make sure the client gets a buffer so they can start viewing the content, and then it will gradually throttle the download speed so you don't eat up all your bandwidth trying to download that file to the client. Okay. Next one is geographic upstream. So before we move on, any questions about rate limiting? You guys are pretty quiet during there. Usually I get a lot of questions. Nope. Okay. Okay, well, we're about to get into some more advanced rate limiting now. So when we talk about geographic upstream, this is requiring the GeoIP module. So if you're going to use the GeoIP module, it also requires the MaxMine database, which contains all the city and region codes and things like that. So what you can do with this directive is if you use it in conjunction with something called a map directive, which we cover in the other courses, you basically create a hash map of relationships between these two values or variables and values. So here you defined the location of those data files. So you have GeoIP dat, GeoLight city dat, etc. And you could use GeoIP country, GeoIP city, etc. And this will be a data file with the ranges based on the region code. And then you can use a map, like let's say you want to use the GeoIP city continent code, which is a variable that's included with the GeoIP module. And then you create this custom variable called nearest server. So what we're doing here is we have the default, which is going to be an empty string here, or an empty value. And then you have other region codes. So EU is going to be equal to EU, NA is going to be equal to NA, et cetera, et cetera. And as you can see in the rest of the configuration, this is mapping to basically where the request comes from. So this request, if it's in Europe, is going to go to these European servers in this data center. If it's in North America, it's going to go to these servers in North American data center. And the proxy process is using that custom variable, which we defined in the map. Okay. So that was GeoIP. The geo directive is a little bit different. It allows for more intelligent routing based on geographic location or range or IP. And you can also create variables that are going to be, processed differently depending on the IP address. So here's some examples. Here's an example of country. So we have default, which is ZZ. Then we have the include, which is maybe a separate configuration. We have a delete. So we're deleting the localhost IP CIDR range. And then we have proxy, which is for this range, and then we have proxy for IPv6. And then you also have specific ranges for specific region codes, right? So these are the different classes, I guess, for these geographic regions. And then another example, you have country. You can just do ranges, which is a part of the geo module. Then you have default, which is the region code. And then you manually specify the ranges and what region codes they specify with or that they associate with.
So just to be clear, is this mapping that we're looking at now an alternative to using the databases that you referenced in the previous slide?
Exactly.
Okay.
It's an alternative. In my opinion, geo directive is a little bit more flexible with some of the examples you're about to see in a minute when we're talking about advanced rate limits. You can use them both together. The geo is a good way to define variables for specific IP ranges. So it's a good way to like blacklist certain IPs in certain regions, for example. Whereas if you're using CIDR ranges, maybe that IP in a different region you want to allow, So you'll see in the next example what I mean. Okay, so here in this example, we're making use of both the geo and map directives. So in this geo example, we're assigning a value of 0 for our limit, $limit variable. And these are basically for IP addresses that are going to be in our whitelist, and then 1 for all others. So by default, we set default to 1, which means all IPs are pretty much blacklisted. And then we use a map to translate the values into a key. So these specific IP ranges, and actually, sorry, this is not a blacklist, this is for rate limiting. So these ranges here, we've pretty much allowed, or they have unlimited rate limiting. And the ones that we define, or that aren't these IP ranges specifically, we've pretty much defined them using this predefined variable. So in other words, this map is basically saying the limit, which is the variable we're taking in from the geo directive, whatever the value of it is. So if it's default, this range or this range, it's going to be set to an empty string, or at least this variable is going to be set to an empty string. If it's 1, meaning if it's anything other than those ranges, we're going to set the limit key to our predefined variable, which is the binary remote address. So that means the client's IP. And now what we're going to do with this limit underscore key variable is look what we're doing here. So we're doing a limit request zone. We're setting that as the key. We're setting a zone name of request zone. We're setting a shared memory zone of 10 megabytes and then 10 requests per second. And basically what's happening here is unless the address has been flagged, they get unlimited access. But if they have been flagged using 0, then they're going to have a rate limit applied to them. And that's for all requests because it's hitting slash. Okay, so we're actually going to do this exercise. If it's not clear, we're going to do it, but I think we should take our next break first. So it's 11 o'clock. Let's come back at 11:10. And when you come back, we're basically going to set this up for localhost. And you can also set this up for your current IP address as well. But if you don't set it up for your current IP, you'll see the rate limit applied to you, which is kind of interesting. Okay, so it's 11. Let's come back at 11:10. Does that sound good?
Yep, sounds good. Thanks.
All right. Yeah, I can hear you.
Okay, thanks. I'm still having nothing but problems on my computer. I've even gone so far as to turn off my company computer that has a VPN connection, seeing for some bizarre reason if that affected my router. But I think my router's shot because while we've been having this morning session, I've tried upgrading firmware and it states it completes it, but never actually takes effect.
Interesting. And are you at home or are you at work?
I'm at home.
Okay.
Yeah, I work remotely.
Right.
So, anyway.
Can you have you tried SSHing into some other box that maybe you have access to, or that you have if you stand one up somewhere, or I don't know.
Well, from my work computer, I was able to SSH into pretty much anything in the office.
Okay.
Earlier this, no problem, but that's through our VPN connection.
Right.
I just don't know. But I can't even ping the server question, the server that's assigned to me.
Right.
Which is really strange.
Yeah, that is strange. Trying to think what the other options might be.
But what's odd is I can get to Amazon Web Services website. That's the weirdest.
Yeah,
it's almost like I have a selected range limit that I can't do.
I wonder if you can share your screen. Do you have an option to share your screen in the interface? Maybe I can see what you're doing.
This session is being recorded.
Should be at the top.
I see. Take keyboard mouse control. I see my name.
Maybe students don't have that option.
Probably not.
Yeah, that would make sense. Well, you know what we can do? How about this? So after we finish today, I can send you a Zoom invite, and we can try and troubleshoot it together after class. Do you want to do that?
We can give it a shot. I was actually wondering maybe if I should just bow out of the course and maybe take it the next time it comes around, and in the meantime try to resolve my issues.
Yeah, you can do that if you want to. I can put you in touch with Bob, and he can give you. He can enroll you in the next course, and I'll still send you the recorded videos and stuff, so you can watch it and maybe try it on your own time.
I appreciate it. Thank you.
Yeah, it's up to you. You can stick around if you want, or yeah, just let me know what you want to do, and then I'll accommodate whatever your decision is.
Thank you. Yeah, actually, if I can have that machine stay up for a little bit, that'll help me to figure out if I can get this thing working or not.
Yeah, I'll keep up the machines for most of you guys till Friday, and then I'll probably tell them by Friday.
Okay, thanks. Let me continue filling with this. I'll let you know.
Okay, thanks for the heads up.
Thank you.
All right, so that's a great time. It looks like everyone's back. So let's go ahead and move on. So let's start with this lab. So we're going to set our geo limit rate right now, or rate limit. So the first thing we're going to do is open up our main config for our DVWA. And the HTTP context, which is basically anywhere outside the server, is we're going to define it up here. So we're going to do geo $limit. It's basically the same example that was in the slides, just a little bit truncated. So we're going to do default, and then we're going to do 127.0.0.1, and then 0. And then finally, we're going to do map limit limit underscore key. We're going to keep this really simple. We're just going to do 0, 0, quotation, 1, binary remote address. Okay. So that's step 1, or it's rather 2.1 in the labs. The next step, after you've completed this portion here, is we're going to define our limit request zone. So I will do that next. So we can do this actually right below it, just so everything's in the same proximity. So we can do limit request zone, limit key, the name of the zone, request zone, define the size of 10 megabytes, and then rate equals 10 requests per second. Then we have limit con zone, server name, zone equals con zone, 10 megabytes. Now, once you have those defined in the HTTP context, we need to actually apply them somewhere. So we can do it either in the HTTP context if you want to stop it before it goes to the SSL server, but it's probably better to do it here. So let's do limit request. I guess the one benefit of doing it up here is you don't have to go through the SSL handshake, but you know, or it might even be better to do it in both places. So let's do zone request equals request zone equals 15, no delay. And I know in the slides it says WordPress proxy. Ignore that status zone. That was from an old iteration of the course. Oh, it's okay, Chris. You didn't miss much. We're just doing the labs. So we started on lab 2.1, which is what I did up here, actually from the limit rate up to here. And now I'm just applying the rate limit in the server context for each. So that would be limit request, and then we're going to do limit con. So limit con, and then we called our shared memory zone con zone, and then 2. So I'm going to do 2 connections per client. Actually, that's kind of low. So why don't we do, let's do 10. 10's enough. Because I think there's a lot of resources for that web page. Okay, so I will leave this up for everyone to look at. So again, the key things to remember here, let's see if I can get everything in the frame. Key thing to remember here is that we've defined geo and map in the HTTP context, as well as our limit rate shared memory zones. And then we have invoked them basically in the server context here. Now the cool thing is, I'm going to reload this really quickly. I'll come back to it, but I want to show you something. Let me go ahead and open it back up. If I go back to my dashboard page, if we go to the shared zones, actually, look what happens here. So you actually see the memory usage and the potential amount of memory pages. Now this is a very small machine. This is like a EC2 T1 micro. So it's not actually that much. It doesn't have that much capacity. But you can see that we're still only using about 1% of it at the moment. And the same is true with our metrics for our upstream. But every shared memory zone that you define will show up here in this list, as well as its usage. Okay, so everyone give me a thumbs up or say something in the chat window when you're ready to move on.
This is Chris. I think mine's working good.
Okay, cool. Yeah, we actually haven't tested it yet, but I'm sure it sounds like you did, Chris.
Oh, I meant the dashboard. Sorry. Yeah,
Oh.
no, we actually have to throw some traffic at it now.
Yep. And if you want to, for all you people who know how to use load generators, feel free, go nuts. But we haven't done that yet. So, okay. How about everyone else? Everyone else good? Okay, you got one message. Okay. If you fell behind a little bit, don't worry. We still have a couple more steps we need to do. So the next thing we need to do is set up logging. And the reason why I say logging, yes, we already set up an access log and error log, or it was already pre-configured for you. But what's really interesting here is we want to set up a separate log for our rate limits. And then we can troubleshoot and actually identify kind of like why the rate limit was exceeded and who was doing it, and decide what to do from there from a security standpoint. So there's a couple type of logging in Nginx. There's general access login and error logs, but there's also the limit rate log level. And this is for, if you want to modify your limit rate logs. There's also debugging connections, but that's more for like internal troubleshooting. And that's not really what we're going to talk about today. So with limit rate logging, by default, Nginx is going to log these requests that are either delayed or dropped due to the parameters that you set in your rate limits. So this is just one example. It will show up in the error log, and it will show up as a limiting request. So the excess was 1,000. It was done by zone my limit. And here's the client. Here's the client offender. Then you have the server host request header, and then you have the request method as well as the HTTP version. And then again, the refer. I think one of them actually is the server name directive, and one is the host, the proxy host. But of course, they're the same here. So Nginx will also refuse any requests that are the request at the error level, as shown by the error. So in the example above, it delays requests at one level lower, so info by default. And to change this logging level, you can use the limit request log level, and then you can reset it to something like warn. So let's show what that looks like here. Oh, the other thing you can do, which is actually super useful, is you can set the log limit request status directive, which will specify which response code to send to the client when a request is refused because either there was a timeout or the rate limit was exceeded. So for example, instead of a 503 code, you can send a 444 code, which is the non-standard Nginx code for closing a TCP connection, useful for your, again, denial of service attacks. Or let's say it's a rate limit exceeded and it's not because it's an internal connection and it's rate limit exceeded. You can send, I forget what it is. Someone correct me if I'm wrong, 418 or something like that. And then, or no, 418 is for something else. That is for too many connections, I think. I'll have to look it up. But anyway, you get the choice to serve a specific response code based on the way that the rate limit was exceeded. Okay, so let's go ahead and test this out. So first thing we're going to do is reload if you haven't already. I want you to check the access log. And here's where it gets kind of tricky. So I want you to open up a local shell on your local machine. So basically don't do this in the instance that you're making your configs in. And you're going to run this below. Again, I put this in red so you don't do it because I don't want you to crash Nginx. Plus you're going to get false positives. So we're going to run this in on my physical laptop, and we're going to hit our machine with a bunch of requests. So you should see a bunch of 503 responses. So let's go ahead and open this up. Oh, it looks like there's nothing there. Nginx has reload. Oh, that's because we didn't name it main, of course. We named it something else. Let me go ahead and see what we named it. We named it, oh, look at those rotating logs. What did we call it? Yeah, I guess we did call it main access log. Okay. So that's the main access log. We don't see anything at the moment. I'm going to open up a shell on my local computer. I'm going to, first I'm going to create a temporary bash variable for WAF host, much like I did in the other machine. So I'm going to do WAF host, just because it'll be easier to run the loop. Make sure it worked. Yep. And then I'm going to go back to my slides. So I'm going to do for I in 0 to 50. Sorry, this might not be big enough for you to see. Let me do it again. Okay, is that better? Duro curl is. We're going to make sure it's HTTPS.
Yeah, that size is fine.
Okay, cool. Host. Do head 1. And I'm really just typing this out so you guys can catch up. Okay, so when I run this in theory, okay, so I got a bunch of 503 codes. And when I check the log over here, at least in theory, it should have shown me something. So I think this isn't the right log file. Let me double check. And that's because I don't have an access log here. Okay. Ah, I remember we skipped that step. That's why. Okay, so let's do error log bar log nginx main.error.log. We can set this to info. And for access log, I'm not going to do that custom format. I'll just do the default. Main.access.log combined.
Are you wanting us to make these changes here, or is this just something that you're doing?
Yeah, we should.
I'm a little bit behind, I think, where you are.
Yeah, let's go ahead and make those changes. So this is in DVWA. We're basically just going to make these changes here.
Okay. All right, I'm caught up with this.
Okay. So we just need to reload. Open our log file again. I'll run the for loop one more time. And you can see here, we get a bunch of 503s, right? So we get a couple 302s, but we can see that the rate limit is being applied. But this is not very good if this was a long-standing, for loop and someone was trying to DOS us right now. So also another thing I didn't point out is look at all these headers that are being sent back to the client. That's not necessarily a good thing. So remember when we talked about proxy set header? There's also the option to proxy ignore headers. So you can set proxy ignore headers, and you can, set things like set cookie or location or expires, and all that kind of stuff. Cache control, you can ignore it. Just to hide it from the client anyway. Okay, so
I'm not seeing anything populated in my I'm not seeing anything populated in my log file. Let me curl this again. Are the logs that we're capturing there for anything hitting localhost?
It should be, yeah. Let me see. Should work at localhost. Yeah, that last curl request went through. Want me to open up the config again?
Yeah, if you don't mind. This is the DMVA config, right?
Yep. And
what I'm missing.
Yeah,
DVWA, I mean. All right, so I got geo, I've got map. My limit is in a.
You set this too, yeah?
Oh, that's what I'm missing. No, I didn't have that. Stream, I've got that. Server, I've got that. I think I've got everything else. Let me save that and reload and try.
Okay.
Okay, yeah, I've got it now.
Sweet. Okay. So the next step we're going to do is we're going to adjust the logs a little bit so that we don't actually, for A, we're not going to serve 503 codes to the client. We're actually going to close the TCP connection after it reaches the threshold with our non-standard command. So what this will do, first thing we're going to do is we're going to adjust the limit request log level. We're going to set it to warn. So it's going to be a little bit more, it's not going to use info, it's just going to use when there's a warning. We're going to set the limit request status to 444. So that means once the rate limit's exceeded, it's going to send that as the response rather than a 503 or something else. Now, I do get this question a lot too. Can you specify different limit request statuses? And the answer is yes. You just need to set this as a variable that's a number. And then it's really complicated. And I have examples if you're curious, but you basically need, it's a combination of using a map and an if directive to specify how the rate limit was exceeded based on which rate limit was exceeded, whether it was connections or requests per second. Anyway, not important for today, just wanted to point it out. So in here, I'm just going to add it so it's all together here. Oh my goodness. I'm getting bad latency, guys. Apologies. And then I'm going to do limit request status 444. Okay, so these are the two lines that I added just right here. So limit request log level and then limit request status. So after you save and reload and rerun the test, you should see different responses.
So this is Chris. Did you change something in the log formatting? Because I'm not seeing anything on the main access log file.
Here. What I did is I added.
You didn't pick.
Yeah, go ahead. Go ahead, Chris. Did I lose you?
No, I'm just looking at your screen, seeing what.
Yeah, in terms of the log, these are the only 2 lines I added.
Okay, gotcha.
Okay, so let me go ahead and reload this really quickly. Gonna look at the access log one more time. Run the for loop one more time and see how it stopped there. Look at all those requests. So 444, and the benefit of the 444 response is that it closes the TCP connection immediately as soon as the response is sent to the client. So it won't stay open and hang. It won't time out if you have like a long timeout configured. It will pretty much just say nope, and then close the TCP connection. Okay, so I'll leave my config open for anyone if they're still dealing with that one. Let me know if you need more time, or let me know when you're finished, rather, and then we'll move on to the next section.
I'm good.
Does anyone else need more time? A couple minutes, maybe?
Yeah, I could use 2 more minutes.
Okay, you got you.
If you get this loop to work though, this for loop, I don't know what I'm doing wrong.
It's not working on your local machine.
Well, I'm on a Windows machine, so I'm trying to transcribe it to PowerShell. I also tried opening up a second SSH session into the same VM. I thought that might work, but it doesn't seem to like that either.
Yeah. You know what you could do? You
I just
instead,
hammered curl 20 times in a row.
Yeah, you could do that, or you could.
I had to switch to my Mac to use the curl command.
Yeah.
I'm on Windows and I don't have time to load tools, so yeah, that's why I got 3 screens going now.
So Chris, maybe you can grease the wheels a bit, but I've been really trying hard for a partner engagement with BlazeMeter, you know, the web-based load generator. And I was like, that'd be really good for
I've
training.
never used it.
It'd be really good for training at least, you know, because you can send, you know, really flat tests, you can send really hard tests, you can send like, you know, complicated, you know, SQL injection, you can do all those kind of things.
Right. I mean, if you're just looking for a way to do this during training sessions, it might be easiest just to use Fiddler or Postman or something.
Yeah, Postman, that's a good one too. We usually use Work when we do our load generation. I don't know why I didn't do it for this example, but Work's pretty easy too.
Yeah, that's a good point. Let me just fire up Fiddler and use Composer to.
Yeah, if all you really care about is seeing the response codes, then you can use virtually anything.
When you do curl-k, is that a get?
Yes, I think by default it's a get, unless I specify otherwise.
Okay.
How about anyone else? Does anyone else need more time?
Okay, this is Genchi. I'm done as well.
Okay, thanks, Shenchi.
I'm good.
Okay. Well, if you guys want to try to crash these things on your own time, feel free. But let's go ahead and move on. But if you do crash it, I'm not restarting it for you. Joking, but not. Okay, so we adjusted the rate limits. Now we're going to do something a little bit more interesting with the rate limiting. So I'm not sure if you're aware or not, but the key val directive is one of our newer directives. And what it does is it allows you to create a shared memory zone to store key value pairs. So the key val will establish what's called a key and then a target value. And then you also have a state parameter, which basically specifies if you're going to write it to a permanent file, like a JSON file, for example. So some potential use cases for this are, what we're going to do, which is dynamic IP blacklisting. But you can also think and be creative with however you want to use this. So if you have some server-side scripts where you need to store some values and then calculate them, this is one good way. If you want to manage redirect rules dynamically using, key value store, you can do that. Maybe you want to have a list of permitted API users via keys and values, or maybe you really just want to route IPs based on backend service based on specific headers, or web token or URL arguments that you're basically going to store in the key val directive. So there's a lot of.
Have you seen anyone use this as an impromptu crypto key store, like for assert key pairs?
That's a good question. Chris, have you ever encountered that in when dealing with customers?
I'm sorry, say that again.
I was wondering if you could use these key zones to hold a certificate and its corresponding private key, like a key store almost.
Yeah, that's a use case that I've heard people talking about when they want to have, specific certificate key pairs assigned or only used with specific types of traffic or specific clients, or, I guess there's quite a few different reasons why you would only have a narrow mapping, if you will, between a certificate and some particular user or some particular, URL or whatever it is, right?
Yeah, I guess I was thinking as an alternative to having those values in flat files on the file system. Would there be any advantage to putting them into this key zone, or is it protected in any way or not?
So this key zone is shared between the Nginx servers. So if you have more than one, like if you have a cluster, this is a way to have it shared among multiple servers rather than having to keep that flat file configuration you're talking about synchronized between the individual servers. They also modified or enhanced the certificate loading process in Nginx Plus with the latest release, in that it's dynamic rather than statically loading all of the certificates in memory. When you reload the Nginx config, it loads them in memory on demand. So it only loads them when a client hits that particular location block. So that's a new feature, only a few months old, dynamic certificate loading. So if you're concerned about that use case, then I would point you more towards the dynamic certificate loading rather than using shared memory across the cluster for large objects like certificates, right?
Okay, that makes sense. And you called it dynamic certificate loading?
Yeah, it came out with the last release, version 16 of Nginx Plus.
Yeah, actually, I forgot about that too. Thanks for bringing that up, Chris. Let me share the release notes.
Yeah, for that use case, that's yeah,
that's actually an awesome use case.
So for large configs with a lot of certificates, that's pretty popular.
Okay, I'll share this with the class. I think that's something I need to update the slides with too. Just the key val cluster awareness, and also what you just talked about, dynamic certificates. Cool. The benefit of having, Internal
Another pair of
employees.
ears. Yeah.
On-demand messages and answers. Okay, so yeah, the key value directive, pretty cool. It's a relatively new directive. We're still learning about new use cases that customers use it for, but sky's the limit. As Chris was kind of pointing out, there's various use cases you can apply to it. What we're going to use it for today is particularly with IP zones. So we're basically going to use it to deny dynamically IP addresses. So here's just one example of how it works. So here we're using it for a way to manage vanity URLs for a website. So if you think of something like WordPress with its vanity URLs, and in the key value directive, the key is set to a URI from the remote machine that's issuing an HTTP request. If the URI is a key in the key value store, the value associated with the key is assigned to a new variable called $target. Then we have an if directive, which basically in the conditional, it says if the target exists, basically, our content handler is basically going to return a redirect code, which is going to permanently redirect to our target. And to populate the key value store, you can do it manually if you want through like a curl and then the API command, or if you have mechanisms to do it programmatically, we recommend that as well. So you include it in your client-side script or whatnot, or if you have a server-side script, you can programmatically upload or populate the key value store with the JSON header and payload, using, of course, the Nginx Plus API. And as a simpler way to restrict,
is that a catch-all at the end?
Which one? This one?
The final location block. Is that at the end? Is
this one. Yeah, this is
Yeah.
this is for all requests, basically.
Okay. Okay. Yeah, I see. I guess I was wondering what happens if there's not a match. It just doesn't route the request.
Yes, that's what happens in this scenario. It basically just goes to the location or whatever the matching location was and translates it as is, So I think there's actually a server block
I
missing
see.
here.
Yeah.
It's kind of not clear because we don't know what's in the key value store, but
Right.
yeah. Instead of having
that's true. There could be a wildcard at the bottom of the key value store.
Right. Was someone else going to say something?
Yeah, I was just going to say this is the API block, right, to enable you to read and write data to the key value store. It's not the actual website traffic, right?
Ah, correct. Yeah, this one here. Oh, actually, yeah, I need to check this example. This is one that's in my notes, so maybe it could be just syntactically wrong. But yeah, that's the idea here, is that this is for the APIs, and this is in part of the server block, and this is the actual location where if there's a prefix match or whatever match for the host name, it's going to go to this backend, this nebulous backend server. Okay, so restricting access. A more simple way to do it is to basically allow and deny. So you allow your company IP address, your network gateway, whatever you want to do here, or your personal IP address, and then you can add multiple allow directives, by the way, and then you can deny everything else. So this is the easiest way to blacklist and whitelist IPs for a given location. And ones that you may want to do this for are your API and your dashboard, which we haven't done because we want to be able to view it from our home or wherever you're taking the class from. But obviously in a prod and even staging environment, you would implement this kind of strategy. Okay, so for dynamic IP blacklisting, so this is more for the use case of you've identified an IP address that is either malicious or you've discovered a new IP address that's trying to do something that's out of the ordinary, that you can blacklist it immediately. So what we're going to do is we're going to open dvwa.conf. We're going to enable the keyval zone with the state parameter, which means we're going to write it permanently to a file called one.keyval. And the key val data store is we're going to map the client's IP, which is going to be the remote address, to the target variable, which is going to be our key val zone. So let's go ahead and do that next. So I'm going to open up the file. I'm going to go into the key. So we can do this in the HTTP context. I'm just going to do it up here. So we'll do key val zone equals 1 with a size of 1 megabyte. Key val. And then we also need to define the target as well, or the mapping rate rather. So this is going to be remote address. And then we'll do target. Okay, so one thing we don't have for this particular server is an API prefix. So we need to create that as well. So I can do that right here. So we'll do location/API. Now, in order to do anything besides a get method, we need to enable the write parameter. And I am going to allow this only on localhost because I'm going to do everything from this machine anyway. And I'm going to deny all everywhere else. So on this particular server, we can issue API commands, but only from localhost. And then finally, I'm going to specify the key val directive here. So I'm going to do if target is true. That's our conditional. And then in our content handler, we're basically just going to return a forbidden response code. Okay, so I will leave this up for you. Let me go up a little bit farther so you can see the key val directives. Okay, so key val directives, and then in your server context, you're going to have an if block, and then followed by a location for the actual API.
Talk me through the why we did that 403 one more time.
So what we're going to do, we haven't populated the key val yet. So the key val is where we're going to hold basically it's going to be the key is going to be the IP address, and the value is going to be sort of like a Boolean logic, like 0, 1. And then basically, if it's true, aka 1, return the forbidden code.
Got it.
Okay, so I'm going to save this. Oh, I misspelled something. My fault.
And with the key, I want to make sure I understand the ordering of the variables that you used with the key val command. So the first variable is the source IP address, and you're capturing that on the incoming request.
Yep.
And then the target variable is that the name of the key store that you're adding the value to?
Yes, it's going to be whether it's a 0 or 1 value.
But right, the Z1 is 1, but before that, the target variable is you're just specifying the name of the key val store, if you will.
Yes, yeah, it's just the name of the value for that particular key. So this is the key. This is going to be the name of the value in JSON format, basically. So this would be like remote address : and then this would be the number 0 or 1.
So that's going to be reused basically for every request. It's not like there's a persistent key value pair store with all these IPs of multiple requests, right?
Yes. In this particular use case, there will be. So every IP address by default will give a default value. So its target value will be, 0 or 1 or whatever, because the way we're executing it is for every request here in the server. So any request that matches this server, once this server binds to the TCP socket to serve the response, it's going to run through this if calculation here. It's going to say if the target's true, return a 403. Now you could do this in a location context if you only wanted to do it for a specific location. You would just need to move this if block into the location. But as we're doing it for every request essentially.
Okay, yeah, and that makes sense. I guess I'm still just trying to understand the actual key value or the key val directive that we have inside of this server block, or actually it's not, it's global, like you said.
Yeah.
Does, for all server blocks, that's just capturing the remote IP, and so the target variable, is that, like in my head, I'm picturing like a hash table with many remote IP addresses that are stored, and if that's what we're doing, how are we giving them all the name or target? It seems like that would have to be dynamic and change, right?
So it's the way it's working.
So this is actually just doing a lookup on a static file. Yeah.
Yeah.
But you're right. If you were doing this in production, you would be managing the key val file and changing which IP addresses are in that, because those are the ones you want to blacklist, right?
Mm-hmm.
So right now, if you ran through this the first time, you haven't populated any IP addresses in the key val store, so everything is going to have access. Isn't that the next step in the lab probably?
Yes.
Is to add an IP address to blacklist, right?
Right.
Okay, it might make more sense when I see the next step then, so.
Yeah, it's the next step, yeah.
Yeah, so let's see the next step. So we already did that. Yeah, so now we need to populate it. After you reloaded it, you as the Nginx admin or system administrator, from your machine, you're going to send a post request. So you're going to basically create the application type, which is going to be JSON. You're going to set the values here. So this is going to be an IP address, which this is like a known IP address. And then you're going to set it to 1, which means it's going to be true. And then you're going to associate it with a specific API endpoint, which is our key val store that we just created, keyvals/1. And then that's where it's going to store it in that flat file, which is 1.keyval. So if we go ahead and do this, and actually I recommend changing this number to maybe your computer's IP address or your network gateway IP address just to see it work. And then you can always change it back too. So let's do this together. First, no one hack me, because I'm gonna show you my IP. Let's see.
Be careful what you ask for.
Looks like I'm going out as, I think this is what I'm going out as.
Yep.
Yeah. So we do curl-k. I know Janchi is going to do something. I just don't, he looks like a guy I don't trust. Just kidding, man. D. Oh yeah, sorry. Because it's JSON. Yeah, and I'm just doing this slow so everyone can catch up and watch me fumble through the command line. And have time to write down my IP to DDoS me later. And then we're going to do version, actually, let's do version 3 because I think it is version 3. We just didn't update the slides. We're going to do HTTP keyvals 1. Okay, so you should see a HTTP 201 created. Now I don't even need to reload. This is one of the benefits of the keyval store. So I don't even need to reload Nginx. I just go here. I go to API. I go to 3. HTTP keyval. Was it keyval or keyvals? Keyvals 1. And I should see the value here. Okay, so that's my IP. It's in there. Now if I go to the, in theory, if I go to the dashboard here and refresh, let's try this one. It could be web cache. Let me see. Developer tools, where are you? Oh, I didn't set it in that. That's why. Okay, let's try here. So we go to the DVA root into the web cache. Okay, I must not be going out as that IP. Let me see if I can grab it. Ah, okay, it wasn't the correct IP, which is fine. Sorry, I'm getting some latency, guys. Okay. Okay. There we go. Okay, so now it's working. So basically I blocked myself from anything on that was listening on that server. But notice how my dashboard still works because it's on a different server listening on port 8080. And we can see our keyval store here. So it actually showed up in the server zone metrics. Okay, so I'll give you guys a moment to do that exercise. Once you've actually populated it and got it working, the next thing to do would be to delete the entry so that you can actually see your website again. So does that make sense, Chris, after we did the exercise?
Yeah, it does. So I added my Amazon VM's IP. I was actually going to go open the file and look at it. That's what I'm doing now.
Okay, yeah, we can do that maybe together.
Where is the 1.keyval file? Does it put it in the same directory as the config file?
That's a good question. Chris, do you know where it is? Where does it store it by default? Is it Nginx?
I was just doing a find dash name to look for it.
Yeah. I'll look it up in the documentation really quick.
Yeah, I did a find dash name and didn't come up with
Didn't find
anything.
it either. I think you have to have a path. The last time I did a key val or a state file, I thought you had to have the full path, like, you know, var run or something like that.
Yeah, because I think if I don't specify a path, it's going to store it like in temporary file. So let's try that.
Var or etc Nginx.
Yeah, I don't want to change permissions, so I'm going to do it like this. Okay, and then if I do another request here, it'll populate the file. Hard reload, obviously. And let's see if it's there. Nope, don't see it. I will ask Rick, and maybe he would know.
Okay.
Yeah.
And then what was the URL that you had to actually see that we are blocked?
Oh, I just went to the login page of our index or our default server. But yeah, so the next thing I should do is basically delete, right? I should delete the entry.
I'm not getting a. Let me make sure I reloaded.
So when I did it the first time, I sent the wrong IP address. So that might be a problem.
Yeah, actually, hold on. Yeah, I was gonna get my SNAT or my HideNet and see if it works for my office. Yep, that's cool.
And this latency is crappy. Oh, the other thing you could do is you could set it to 0, but I'm actually just going to delete the entry entirely.
Set. Oh, I see. Yeah.
By the way, I recommend using the Node.js module, or the Nginx module, Nginx JavaScript module. I haven't had enough coffee today. The Nginx JavaScript module to attempt to do some of this programmatically, but there might be other solutions to do some of this stuff programmatically, like if a rate limit's exceeded, it automatically add it to the key value store and blacklist it, for example. 4.4 not found. Great, awesome. Oh, I used a different version. That's why. What was it? API version 3. There we go. So no content. Do a hard reload. Should work now. Yep. Okay, let's take our last break for today, and then we will go into the last section. But before we do that, this is what Chris was talking about, by the way, in the slides. So I remember I did update the slides because that's what I should do during new releases. So this is about the cluster-aware rate limiting. So aside from the key val being cluster-aware, you can also make your rate limits cluster-aware. So if you want to define local rate limits, but also global rate limits that would share across the cluster, you can do that. And you use it basically with the sync feature called zone sync here. And this is really good for API gateway use cases. If you're delivering APIs to service level, to an SLA that prevents clients from exceeding a specified rate limit, you can do that. It does not require a primary or a master node. In this case, all with the rate limiting, at least the way I understand it, all nodes are peers and exchange data in a full mesh kind of topology. And as long as the Nginx plus state sharing meets a couple network connectivity requirements and such. You also have the cluster-aware key value, which is specifically what Chris was talking about. So the entries are synced across all nodes in the cluster, but they must be configured like the previous example for state sharing. Okay, So let's take our next break, or our last break rather, before we go into these last two sections. They will be pretty fast. I actually don't think there's any labs in these last two sections. So we might end a little bit early, maybe around 12:45. So it's about 12:07. Let's come back at, well, actually, let me ask you guys this. Do you guys even want to take last break, or would you rather power through?
How about a short one?
So like a 5-minute break?
Sounds good.
Yeah, so it's 12:07.
Yeah.
Let's come back at, I don't know, 12:12.
Yep.
Okay.
Okay.
So for authentication, we're going to speed through some of this because some of it is no longer applicable, or we actually don't have any labs for this section, nor do we have labs for the performance tuning section. So feel free to stop me at any time if I go too fast or if you want me to retread over something. So during this section, we're going to talk about some of the basic methods of authentication. So we're going to talk about basic auth, setting sub request authentication, authenticating content like with secure links, and we'll also talk about handling hybrid and multi-cloud access control. What we don't talk about here is kind of like advanced authentication, which we will cover tomorrow, such as like OAuth or API client authentication. So basic HTTP authentication, basically it can be enabled anywhere at the HTTP context level or below, and the off parameter is used to turn off authentication. So this is actually a pretty old method of authentication, and I generally only recommend it for things like if you're in a test environment and you want to authenticate against your dashboard, for example. This is a good methodology. Anytime I see this in a prod level website, I kind of irk myself because I think it's really easily attacked, especially if your crypt file or your password file is compromised. But basically the way it works is you have your basic auth zone that you've defined for a specific server or location. You have the location of the file, which is a key, kind of like a key value store. And then basically for any location you want to be publicly accessible, you can turn it off. And the password itself is stored in the file along with its encrypted output. So whatever you use to encrypt the output, whether it's base64 or such, you can use it. You can use certain techniques to encrypt the password. So you can use the crypt, which is an Apache utility, or you can use the OpenSSL password function to do it as well. So there's also the option of authentication based on a sub request. This is actually a more, I wouldn't say safer, but it's a more common use case, especially because customers that we know of want to redirect to some kind of authentication service or maybe some other server even, or an LDAP server to do a lot of this stuff. So how it generally works is you're going to pass specific request headers or the actual full request header itself with proxy set header. And then you're going to set variables based on the response you get back from that authentication service. So whether it forces them to log in through an LDAP or Active Directory, those specific response variables will allow you to access the content. So it's kind of like a sub request of your initial request, in other words. So here's what it looks like in the config. And of course, this is just kind of like pseudocode, so it's not actually going to something called LDAP server or whatever. But here we have the location /private/. We've set the auth request to another location on our server called /auth. And this is pretty much a location that's only accessible internally. It's going to proxy, at least in theory, to something called an LDAP server. It's not going to pass the full body. It just needs some specific headers, so content length, the original request URI, and the response that you're setting that you expect back, and that we don't add here actually, that we probably should, is the authentication status and the upstream status. So this is looking for like a 200 OK or whatever the response code is for authenticated. I forget what it is. And then whatever the authentication status is that you've set in the response. So it's authenticated or validated or whatever. And if it matches a map, which is not shown here, then it will actually be able to go through the authentication. Okay, a better way to do this, honestly, is to use API authentication for something like single sign-on. but we will talk about that tomorrow. Okay, there's also the secure link module. So this verifies the validity of a resource, or a requested resource rather, by comparing it to an encoded string that's actually exists in the URL of the HTTP request. So with that string, it basically computes for the it searches for the request, and also if the link has a limited lifetime, such as like an expiration time, that link is considered outdated and it requires a new encryption string. So the status of these checks are captured in the secure link variable, which is $secure_link, and it's used to basically control the flow of processing. So some use cases for this are maybe you want additional protection against, unauthorized GET requests for downloads and things that need like some kind of authentication header to be sent with the request, or maybe you want to add expiration time for encoded data that's being displayed to the client via browser, and you want it to have a timeout, for example, and then they need to re-authenticate to see it again.
So a question about this, I may be misunderstanding. Years ago, I had the use case where we were trying to serve up some content without requiring users to authenticate, but we wanted the content to be basically to give them a long URL, which they could share if they wanted to, but we didn't want the whole world to be able to easily guess that URL, and so we used a 64-character hash on the end of the URL. Had it expire after a short period of time.
Right.
Is that something that you could do here, where instead of complementing a URL that requires authentication, you instead use this as the only means of protecting what's behind the URL?
Yes, the use case you outlined is another use case too. I just used authentication because it's the easiest example to explain, but the encoded string could just be something you append at the end. And again, you could have a timeout and it's only available for certain people for a certain amount of time, and then it becomes expired.
Is that, so I'm reading what's on the screen here, are you able to adjust the length of that hash?
Yeah, yes. We're going to show the examples and some in the actual directive here, and it actually does outline the use case that you were just explaining. So in this example, for example, we're using the MD5 hash, and we're basically concatenating it with the end of the URL prefix. So a good use case for kind of what you were outlining is, what if it's a video file, right, or a manifest file for a bunch of video TS fragments. And that's what's happening here. So we've concatenated the location and the file name, which is bunny.m3u8, and then we've basically appended the secret to the end of the file. And of course, when you encode it, it looks something like this, right? But the way you encode it in the request is that it's prepended before the actual path to the file in this example. So that's what's happening here. You're using OpenSSL to generate that hash, and then this is what the request would look like when it comes through. Now, what it looks like in the config, however, I showed it in the next slide, but this is just another example, a little bit more kind of what you were asking about. How can you adjust the expiration time? So you can set the base. So using OpenSSL, for example, you can set the date time and then append it to the actual string, and then you can you can go through the whole process again to change the date time as well if you need to adjust the date. Does that answer your question?
Does Nginx? It does. Does Nginx support making that a nonce, where after receiving one request with that value, it becomes invalid?
Yes. You can do it a multitude of ways. You can do it in an if block. You can do it in a map. You just need to set up the logic in the config, basically, to say if request exceeds 1 or something, then invalidate this specific token or this specific request to URI.
Okay. Which
you would probably also need to store in a variable. But yeah, you can do it. The short answer is yes. It's just not easy, from what I understand. But nothing worth doing is easy, right? Okay, so here's what it looks like in the config, and here's an example of if you wanted to expire a secure link. So the secure link directive, basically what it does is it defines two variables that are going to capture the arguments in that request like we showed you in those last two examples. So, for example, we have an argument that's called MD5 as one of our variables, and that's set to the value of whatever the arg expires is. So arg expires is the value of whatever the expiration arguments if we're using our last example. And the secure link MD5 directive also defines the expression that's hashed to generate the MD5 value for the request. So during the URL processing, the hash is actually compared to what you have here in arg MD5. And then the if statements say if the secure link is empty string, return 403. If secure link is 0, which again, this is going back to your point, Chris. If we've set some kind of map that has a Boolean logic to say if the request is 1, set the value to 0 or 1, or you can even do this in the key val store if you wanted to. You can return a 410, which means it's forbidden and needs to be re-authenticated. Okay, did that answer your question, Chris? I just want to make sure we don't move on, if that makes it clear.
Yeah, it did.
Okay, cool. Last thing to talk about with this directive is programmatic hash. So doing this all manually seems like a pain in the butt. So obviously you can create some kind of script to do it for you. So here we have a Node.js function. This is taken directly from the documentation where it's pretty much doing that same thing. It's appending the hash to the request. This is on the client side probably. Or no, it's not because it's Node. So yeah, this is on the server side. And it's basically creating the hash and sending it back to the client. And basically, this is one way you can dynamically adjust the time as well. So here's another example using a map. And this is actually just using the file name as an example, but you could do a number of requests. So this is probably a good template to use, Chris, if you wanted to test this out. But instead of file name in your regex, you would do, if value exceeds 1 or 2, set it to a certain value, and then the value would be executed as it's seen here. So here you can see file name is the variable that you're checking against in your secure link MD5, which we've set in the map up here. So instead of file name, it would be request rate, or something that you want to do. Okay. So next section is going to be security performance tips. So the basic idea here is at the beginning of the class, I talked about how you can tune SSL operations to make them faster and more performant. And that's basically what we're going to do here. So first things first, you have the option to actually run Nginx as a non-root process if you need to do that for security reasons. So let's say, for example, maybe you're running an automated test suite against a local instance of your application. And the whole test suite is operated by some kind of bash script. Normally, you wouldn't set this up. Normally, you wouldn't set this local test environment with sudo. So this would allow you to disallow a password in the sudo user using if we're using Ubuntu, for example, and you want to disallow a password in the sudo user list in that Ubuntu list. But what if you can't do this because, again, that test automation script is running on a build system server that doesn't have sudo rights, Or perhaps it's running off an external Jenkins server that only has specific service account access to the application. So those are two use cases where you may want to run Nginx as a non-root process to give access to something like Jenkins or some kind of build system server. But the problem with this, though, is when you run Nginx without root process privileges, you're going to have to change all of these directories and paths to have ownership that are non-root. And this is the following list. So in other words, if you don't do this correctly, Nginx won't be able to write to the log file anymore, for example, or it won't be able to buffer certain things from the client. So with the client body, if it needs to write to temporary files and things like that. Also, other problems you're going to run into. So by default, if it's not a root process, it can't bind to privileged ports that are lower than 2024. And most web servers typically run on things like port 80, 443. So you'll either have to define different ports or actually that's what you have to do. You have to define that in your config that all the listen directives are greater than 1024. You'll also have to check permissions to the Unix socket configuration too. So if you're using web sockets or control sockets and things like that, you may need to change permissions there too. Also, if you want to avoid warnings at the start with the user directive, should be commented out in the global Nginx config, because otherwise you'll run into a situation where the master process is still running as root, but the workers will be running as non-root, and that can cause problems as well. So, okay, so that's just general if you're running Nginx as non-root. Another good thing to test some of your SSL configuration changes, and this is going back to kind of what Chris Acker was talking about, like if you want to test the dashboard and stuff, you can actually use Nginx as a load balancer or proxy for that test system, and then you can mirror request that live actual traffic to the upstream to maybe if you want to integrate new WAF rules and see what kind of things it catches, or maybe you want to do risk-free performance tuning with live traffic. You basically, the way request mirroring works is it sends the request to the other server, and it basically drops the response, so it's not going to send a response back to the client. So you don't necessarily need to worry about a client getting access to, you know, a different version or a test version of your app, for example. And here's an example of what it looks like. So you have your location slash, you set the mirror directive to something called whatever slash mirror, and then slash mirror is internal only, and it's proxying it to some kind of test server along with the request URI. We already covered this one, so force incoming traffic to HTTPS. I'm not going to go over that again. SSL stapling we didn't cover, but and this is kind of an odd one because it doesn't really make you more secure, but it does help the client pretty significantly in terms of SSL handshakes. So Reader's Digest version, it pretty much helps the client by telling them they can use your server for the OCSP information of your basically of your registered domain instead of letting the browser make the request. And you know, maybe it'll run into an often unreliable resource, or there is the option that maybe it can kind of indirectly prevent man-in-the-middle interception if someone's posing as a CA. But for most sakes, it's just for improving client experience by stapling that OCSP response to your actual server, and then it's just going to be using it for subsequent requests. Okay, so for accelerating handshakes, we have a couple directives here. We have the SSL session cache. So there's a couple parameters I want to go over. So we have off, none, built-in, and shared. Off basically uses the session cache, or it basically says it's prohibited. None basically says it's gently disallowed, which is kind of Nginx speak for saying that it's going to tell a client that sessions may be reused, but it doesn't actually store them anywhere in its cache. So, and then built-in is saying it's going to use the cache built by OpenSSL, and that's usually used by one worker process only. And the problem with this one, though, is that the cache size is specified in sessions, and the size of the cache is not really given. But we do know that around most distributions, it's equal to about 20,000 sessions. But you know, if you're not really aware of what's happening with that cache, it could cause memory fragmentation. So what we recommend is to use the shared memory size, which is something we're familiar with already, having gone through this class. We can basically segment the memory out as we see fit, and we can specify that either for specific HTTP or server context as well. The next directive we have is the SSL session timeout. So this is where the SSL session cache can be shared between workers, and it will time out after 5 minutes by default. So in other words, if a worker will hold on to this session data in its shared memory zone, and if it hasn't been accessed by a known client, it will evict it from that shared memory zone. And then the last one we have is SSL session tickets. So this is one of the most important features to improve user experience, especially for visitors that are visiting your site over something like TLS. And the general idea is you're avoiding the full TLS handshake by storing the secret information of previous sessions and reusing those when connecting to a host for the next request. Now, this drastically does reduce latency and CPU usage, even more so than the session cache, but it introduces kind of a new problem. By enabling this in web servers and proxy servers, if they're compromised, it pretty much negates forward secrecy. So there's an article I linked to it here on some of the trade-offs. I definitely recommend reading it. It also frames it in the context of Nginx a little bit too, which is kind of nice. But that's something you'll have to assess when you're doing your tuning and your performance tuning. So just a little bit deeper with TLS resumption. You can use them in combination. So you can use the session cache to store session data, and then the session tickets will transmit some of the session data to the client. And again, it does potentially compromise certain things like your Diffie-Hellman and HSTS. And yeah, again, if your session IDs aren't purged from the cache, they can be stored on persistent storage. And if a malicious client does intercept the data, you could be SOL. But the performance benefit is paramount. So let's say you use TLS resumption with HTTP2, or let's say you want to use HTTPS when your browser needs to negotiate the session. You can, when you leave the site and come back later, the browser will still need to renegotiate, of course, but combining this effort with HTTP2 allows you to speed up the transfers due to the files that are using the new binary protocol rather than, a ASCII text-based protocols. And there's also no longer a head of line blocking, so you can send multiple GET requests via multi-threading. So this is something to experiment with and see if you get some performance benefits. A lot of people complain, they're like, oh, I added HTTP2 to my HTTP server and I don't notice a difference. I'm like, well, that's because you haven't hit it with enough load to really understand or see a negligible or non-negligible difference. So of course we know the handshake causes a lot of CPU overhead and can slow down some of your bandwidth or even just your CPU or overhead. So why don't this is the best place to try it, right? So use SSL with HTTP2 and you'll see the added benefits. Add that with Keep Alive and you'll see it even more. Okay, so last thing I want to talk about here is encrypted section. Actually, this is an outdated slide. I'm not supposed to necessarily mention this. This is actually if you're using Nginx using OpenResty, and I used to have the GitHub link provided here, but it's not here for some reason. So we can ignore this one. It just provides encryption support for OpenResty using the dynamic encrypted session. Okay, so that's it for today, guys. Thanks for your patience through some of the technical stuff we were having today. Just as a preview for what we're going to talk about tomorrow. By the way, it'll be the same. It will be the same. At least I hope so. It'll be the same go-to training link for tomorrow, and it will be the same time as well. But what we're going to cover is more enterprise level security. I mean, not that everything we covered wasn't enterprise level security, but this is more for people who have the enterprise version of our product. So we're going to talk about how you can secure API traffic using the JOT token or JOT authentication. We're going to talk about authorization protocols. So, combining JOT authentication with something like OpenID Connect, if you're going to sign in using Google+. Then we'll talk about mod security. So that will be the remainder of pretty much the second half of tomorrow. So we'll do an introduction to mod security, what it is, how do you configure a basic rule. Then we'll do some more advanced rules where we'll set up the core rule set. We'll test against a specific attack vector. I think it's, if I remember off the top of my head, it's cross-site scripting. We'll also talk about the OWASP, what's the top 10 attack vectors and whatnot. And at the very end, if we have time, and I will leave the machine up for a week just so you can do it, but we also have bot protection too. So we'll use the honeypot project to prevent against crawlers and bots and things like that. Okay, does anyone have any questions before we break for the day?
Nothing from me.
All right, well, I guess we can break about half an hour early. So I'll see you guys tomorrow. Hopefully this was useful for you too. I know it was kind of a retread of basic stuff, but tomorrow will be the most interesting, I promise. And come ready with your questions. Oh, by the way, Chris, you asked a question earlier. I think I did get a response. Let me see if I get a response.
Yeah, and honestly, I don't remember what the question was.
It was about prefer server ciphers.
Oh, right.
Yeah, it says basically when we outlined your use case, like if a client basically uses an older or newer cipher suite than what's specified in the server config, it basically says the handshake fails and the connection is closed.
Okay,
So, yeah.
So it's basically doing the same thing that you would do with a typical SSL handshake, but using ciphers rather than the version of TLS.
Right.
Okay. Yeah, that makes sense.
It says so the same thing happens whether you use an on or off, kind of because it'll default to the TLS version and what's accepted. It says with the difference with the directive server prefer server ciphers is that the server chooses when this is on. Otherwise, the client chooses.
The server chooses what?
It says in quotes when this is on, or at least the person who responded. I don't know what that means, but it says there has to be a match. Yeah, it says there has to be a match no matter what.
Okay, well, sounds like there isn't a lot to understand there. That it's either way, it's going to. The server is in control of dictating which ciphers can be used, and the client has to comply.
Yeah, I think that's pretty much the takeaway, and it's just, even if it seems somewhat redundant, it's just another layer of forcing the client to do what you say you want it to do. So.
Sure, there's probably some nuance to it that's above my head.
It's definitely it's definitely above my understanding too. So, but
I have seen some websites though send you a help page that says, you know, your browser's, you know, out of date or your SSL ciphers are not strong enough. So rather than just closing the connection, there's some logic there that says if the client doesn't meet the specs that are required, send them, you know, a nice message rather than just, you know, dropping the connection. So
yeah, that's interesting. I almost asked that question earlier in the particular scenario where a client has failed the SSL handshake. You know, it's usually a pretty unfriendly experience at layer 7.
Right.
In other words, it's probably just a 404, but it would be nice if the Nginx server could actually return a friendly error page.
Well, they have the error page directive, and then you can also do proxy intercept errors, which is another directive.
Yeah, I think that's how Nginx does it, is you do a proxy intercept, so it intercepts that error, and then you can replace that with something like a, you know, a help desk page.
Right, but
yeah.
But at layer 7, whether the page failed to load because of an SSL handshake or whether it failed to load because you know, you're dropping TCP packets or like for whatever reason, if a failure occurs at layer 4, I mean, you're going to have a pretty similar message in the user's browser, are you not?
Well, I was thinking specifically of the SSL handshake failure due to either not meeting the TLS requirement or not meeting the cipher requirement, where you were sending them a graceful message before you close the TCP connection without telling them anything.
So when that happens, what would a client normally see in the browser?
Well, normally you would just see can't connect or connect failure or whatever the browser version of a TCP or SSL reset would be, right? A can't connect message of some kind. As opposed to if we intercept that, then Nginx can at least render them a sorry page with some links to, you know, more material or, you know, upgrading their browser or, you know, whatever you want to send them.
Right.
Yeah, I think, but you make up a good point. A 404 error can be somewhat nebulous, right, in what the cause is. Same with like 502 and whatnot. But Nginx does have the capability, like Chris was saying, you can intercept it, specify your own error page, and then in that error page provide possible troubleshooting steps for the client to do. You know.
Right. Yeah, that makes sense, and that's probably something that, you know, down the road we would need to look at in our use case. Is we have a lot of, you know, every problem or every incident that we have, our team gets pulled in because we own the web and API gateways that sit in front of everything that's web facing. And so whenever there's a problem, it's always at least touching our infrastructure, right? And a lot of times it's either a 502 bad gateway or it's a page can't be found because the application that was sitting behind the Nginx reverse proxy is down. And so Nginx is returning, hey, I can't find what you're trying to hit. So anyway, it would probably be advantageous to start instituting some more descriptive error messages that indicate that the problem is, you know, with an SSL handshake or with the backend application or whatever.
Yeah, you know, and that just brought up a point in my head. The last use case you were describing about a page or service being down. Are you guys using caching at all and serving stale content and stuff like that?
SSL caching?
No, just like actual content caching.
Not for the applications. We are using a session state cache. It's backended on Hazelcast, but not not what you're meaning.
Right. Okay. That might be something to explore, though. You know, even just for static files, serving static content, static and stale content
Right.
when something goes down, while Nginx tries to either bring that service back into rotation, or if it's something else like a scheduler like Kubernetes that's bringing it back in rotation. Just so the client doesn't get dropped connections or whatever. Anyway, okay. Thanks for everyone attending, and I will see you guys tomorrow.
Okay, thanks. Bye.
Thank you. Bye.
Thank you. Bye-bye.